Okay, good morning, ladies and gentlemen. It's me again, Rani Raj, and it really is a pleasure for me, an honor for me to welcome you again on this 4 day with Indonesian warmest greetings. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Welcome to the day 4 of Asia Pacific Workshop on Digital Aeronautical Transformation. Can we please give big round of applause for all of us? Thank you very much, ladies and gentlemen. And of course, in this wonderful moment, I would like to say hello, good morning, welcome to our experts today. Miss Dinda Yunita as a Deputy Director of Air Navigation Operations. Good morning, selamat pagi, Bu. Miss Feranti as a General Manager of Aeronautical Information Services Center Airnav Indonesia. Mr. Bagus Sunjoyo, Director of Human Resources Airnav Indonesia. Mr. Farid Zizi, as an Administrator and Executive Director of FRAX. Mr. Louis Giroud, as an Air Navigation Expert of CGX Aero. Mr. Manuel Gabalia, as a Senior Procedure Designer of CGX Aero. Mr. Gilles Grachet, Flight Operations Support Manager at ATR, who will be joining us virtually this afternoon. And of course, distinguished guests, delegates, ladies and gentlemen who have joined us here in Atria Hotel Tangerang and also joining us virtually through our YouTube channel, Airnav Indonesia. Thank you very much for joining us. So ladies and gentlemen, Airnav Indonesia in collaboration with CGX Aero is proudly present to you the remarkable event. Of course, this is our last day. Airnav Indonesia, together with CGX Aero, initiated this workshop to prepare for the change towards aeronautical information management. This workshop will focus on digital aeronautical transformation, which also invited many expert speakers in this field. So within 4 days, we will discuss challenges and opportunities in obtaining, conveying, and processing aeronautical data digitally. So, ladies and gentlemen, how was the gala dinner yesterday? Great. I heard everyone enjoyed the gala dinner. So, how was the dancers? You're all the dancers. Okay. So I hope you enjoyed the gala dinner. And before we start, maybe to energize everyone, Bapak Ibu mungkin yang baru join ya. So we have some kind of pagi-pagi thing. And Mr. Farid Zizi will help me to lead the pagi-pagi thing. Okay, Mr. Farid Zizi. So basically we have some kind of tagline. When Mr. Farid Zizi say, semangat pagi, everyone says, pagi, pagi, pagi luar biasa, okay? Agree? Okay, Mr. Farid Zizi, please stand up to make everyone
Selamat pagi. Selamat pagi.
Can we give big applause for Mr. Farid Zizi? Okay, thank you very much, ladies and gentlemen. So we are going to start our first agenda today, but first let me give you a brief information about our workshop. So as usual, before the workshop started, participants are requested to register themselves at the registration table. Have you registered today? Okay, thank you very much. And each speakers will be given 40 minutes time to present their slides, followed by 20 minutes Q&A session led by the moderator. So in the Q&A sessions, we encourage everyone to participate in the lively discussion by raising hands. So you can just simply raising hand and the committee will hand over you the microphone. Or you can just write down your questions if you want to use bahasa. Jadi buat Bapak dan Ibu sekalian yang mau menggunakan bahasa Indonesia ketika bertanya, kami persilakan, silakan boleh pada saat Q&A session boleh dituliskan pertanyaannya. Nanti panitia akan mentranslasikan ke panelis untuk dapat difasilitasi pertanyaannya. So the committee will translate your questions and to facilitate it to the panelists. Thank you very much. Now, without further ado, let's kick off our workshop today. We're going to start from the first session. And the theme for today's workshop would be terrain and obstacle data and AMDB terrain sorry, and obstacle data and AMDB, with 8 experts who will take you to deep dive about this topic. So I'm going to call upon the stage 2 speakers for the first topic. The first is we will have Miss Dina Yunita as a Deputy Director of Airnav Operation. Miss Dina Yunita, professional in the field of aviation. She achieved the status of Level 5 Air Navigation Inspector in 2016, a testament to her dedication and proficiency. With a career marked by achievements, Dina reached the pinnacle of her responsibilities in 2019 when she assumed the role of head of the Aeronautics Information Management, Meteorology, and Search and Rescue Section at the Directorate General of Civil Aviation in 2023. Ms. Dina Yunita was appointed as the Deputy Director of Air Navigation Operations at the Directorate of Air Navigation. So please welcome on the stage, Ms. Dina Yunita. Ms. Dina will be accompanied by Ms. Ferranti as a General Manager of Aeronautical Information Services Center, Airnav Indonesia. Ms. Ferranti started working at Airnav Indonesia in 2013 and as Operation Integrity and Compliance Senior Specialist. In 2022, she transitioned to the role of Strategic Planning Manager in Corporate Planning, and currently serving as the General Manager of Aeronautical Information Center since September 2023. She is enthusiastic about collaborative efforts to facilitate the successful transition from AS to AM. So please welcome on the stage Ms. Ferranti. So Ms. Dina Yunanti and Ms. Ferranti will bring the topic about AS to AM plan and challenges. And to facilitate this session, I will call the moderator for this session. So please welcome on the stage Mr. Muhammad Ali Megales, graduated as an engineer from INEC in Computer Science and Aeronautics in 2002. His experience has been built through significant involvement in the management and publication of aeronautical information and data. His contributions have been focused on the development and automation of tools and expert software dedicated to data collection, flight procedure design, and aeronautical charting. And now he's working for CGX Aero as a Chief Technology Officer and Business Development Director. Ladies and gentlemen, Mr. Muhammad Ali Megales. I will hand over the session to you, Mr. Ali.
Thank you. Welcome again. Assalamu alaikum wa rahmatullahi wa barakatuh. Hopefully you are lucky I'm not speaking today. I'm just a moderator, so good for you. No more AXM, no more AXM 10, 12. Now the floor is for Airnav, our hosts here, to present us challenges and plans of Airnav to meet and to face all of these challenging aspects that we have been discussing. Hopefully what I understood that is there are many plans that are already running, that are already going, and still to go, still to do. And I let the floor to Mrs. Dina to present us a first part of these challenges and these plans from Airnav.
Tes. Thank you, moderator Pak Ali. Bismillahirrahmanirrahim. Warm greeting in bahasa Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Om Swastiastu, Nama Budaya, salam kebajikan. And good morning, ladies and gentlemen. First of all, I would like to express my gratitude to our colleagues, Aeronautical Indonesia, for inviting me as a speaker in this workshop. And for the for the gala dinner in the last night, very amazing. Thank you. And today, I would like to present, just share what we are doing for the implementation IS2IM in Indonesia. Yes, this title is IM2IM Plan and Challenges. Before we continue to what we are doing in stepping for IS2IM implementation, we just inform regarding our organizational structure in DGCA, because me in DGCA Indonesia, we are DGCA Indonesia consists of the 5 directorate and 1 secretariat director general, 1 directorate of air transport, directorate of airport, the 3rd directorate of air navigation, 4th directorate of aviation security, and the last directorate of airworthiness and operation. And for the main task for the how to we implement for the IS2IM is responsible for the director of air navigation, especially for the sub-directorate of air navigation operation that we have responsible for that. Yeah, this is just take a look what about the global air navigation plan. That this is previously speaker like Pak Farid and another ones explain about how the global air navigation plan, this document to guide state for the manage the locally or regionally for the aviation global. And one of them about how to manage the global navigation plan is the IM, about the aeronautical data. The global situation of aeronautical system, everyone choose a different answer to same problem. And a lack of harmonization between countries. And second one, no worldwide common guideline. The industries are not participating in the decision-making system. And the last one about the situation now, systems are not interoperable. This is what we have to do, improve about our decision. Yeah, this is IQ annexes and document related to the implementation IS2IM, IQ Annex 15, regarding the Article Information Service, document 166, PANS IM, document 8126, Article Information Service Manual, and document 9839 regarding manual KMS for IS, document 999 for manual of IS training, document 9750 Global Navigation Plan, and the last one Asia Pacific Plan for the collaborative IM. This is the document we have to reference, we have to refer to develop the IS2IM. And we share about our regulation regarding to the provision of the IS in Indonesia. As we know, we have the CSR Part 175 adoption for the Annex 15, and we have some manual of standard part of 175. For example, 175.01 for analytical chart, most 175 that's 02 for the no time manual, manual standard 175 part 03 regarding the IP, and MOS 175.04 for the IS provider, and the last one, MOS of 175.05 regarding the quality management system for IS. And also Article Circular Part 175 regarding the organizing of IS. And we know some documents, annex and document IQ is established and established for renew, and for IQ document 18126 for IS manual, and established the PANS IM in 2018. So some manual of standard Indonesia have been developed to review and review for the adoption, by the adoption this document at 126 and the PANS IM. And the last, we have to prepare for the regulation guideline procedure for the collecting, processing, and publication electronic IP using by the IWIS. IWIS, we can tell next my presentation. Yeah, this is the transition from IS to IM. I believe our all participants have know more about this stepping, because the previous speaker that said about that. For like this diagram, we can see the data-centric environment end-to-end, from the data originator till to the user. Yeah, data originator coming from the aerodrome, airport, aerospace, designer, surveyor, and so on. And then they have to make ensure what the quality data is, and then submit to the IS provider to manage, to process, to collect, become the publication, and then distribute to the user. Yeah, this is IM implementation plan based on the IQ Collaborative Aeronautical Information Management. We know that in this document, guidance for us to how to implement IM. We have the 3 phases, like the Mr. Takata present previously. Phase 1 expected to be implemented immediately. Phase 2 expected to be implemented by 7 November 2019. Go. Phase 3 expected to be implemented by 27 November 2025. And now we are in the 2024. Approximately 2 years we have to complete for the implementation IM. And we know in the all the pace in the IM capability consists or talking about the one legislation, policy, and regulation. How to manage, the state give the policy, how we manage the IS to IM. And the second one, talking about human performance. Every space we have to manage the capacity building for the IS personnel and other personnel as well related to the aviation. We have to increase the capacity, we have to conduct the assessment for the personnel and so on. And in this phase, also called about the quality management. Talking about the quality management, we know that the quality management is important to, especially in article data, we have to assure that the data is quality. Quality means like the accuracy, resolution, integrity, in the format, and timelines, and standardized. We have to manage the data. And the last one, IM system and process. This is important. That's why our another speaker talking about the system, because when we talk about the system, the data process can be managed more effective, efficient, and hopefully quality is assured, I think. Yeah, I just shared about the implementation status of IM plan in Indonesia was reported on IQITF 18 last year. The position Indonesia for the phase 1, 90%, 97%, and the phase 1, 46%, and the third phase, 33%. We can see that why I'm phase 1 almost 97%, because any two indicator we have do not full yet minutes. For example, for the indicator number 2, to include IM plan to National Air Navigation Plan. You know that Indonesia still, for the National Air Navigation Plan, have been developing to include the IM plan Indonesia, and position the document is process of finalizing. We hope until finalizing this indicator full implement. And for the indicator number 3, separate entity of IS in the GCA, yeah, we know that we are to, for IS provision in Indonesia, one of the step process in the publication of the aeronautical information product still in the DGCA for the validation and publication. And today, at the moment, we have established the regulation to delegate all process to the airnav. All process to the airnav. We are still make the plan for the transition from DGCA to airnav, how to process all processing in the IEP product. And for the phase 1, yes, this phase 1 is talking about digital, going digital. This indicator in item 10, like the policy, legislation, and regulation to support digital, still developing as well. And then for the ICE personal training and the digital database and manage of database, terrain, obstacle, and aerodrome mapping. We are still learn how to manage the electronic terrain obstacle data and how to manage the aerodrome mapping database. So that's why for the phase 2, going digital, we stayed in the 46%. And the last one, the third phase, like the article information management, we are at the 33%. Yeah, because the data, digital database, and how to manage the ATOT, IMDb, and so on, still going on, and directly for the IMPACE 3 cannot be full implement. Yeah, this is the current condition and challenges. The current condition, updating the policy and the regulation for the National Air Navigation Plan document, adapting the provision and document at 126 edition and document PANS IM to be regulated in most part 175, like I mentioned before. And the last one, establish IM system. We have the IWIS electronic chart. IWIS is integrated web-based aeronautical information system handling that we can share next slide. And for the challenges, engage stakeholder. We have to engage a stakeholder, especially for the electronic terrain obstacle data, IMDb, and another. Because when we talk about the electronic terrain obstacle data, when we talk about the IMDb, it's not just IS function. It's not just IS function. We have to collaborate with the other entity, like the airport, like the supplier, maybe for the Indonesia is like the Badan Information Geospatial, like the BRIN. We have to collaborate with them to manage the electronic terrain and obstacle data. This is the challenges, because beside the entities, we have a large area in Indonesia. We have many airports in Indonesia. This is the challenges for Indonesia. And the second one, develop regulatory framework of IM and swim environment. Yeah, this is the challenges that we have still being developed for this document. System, personnel, and so on. And the second one, develop and manage ETOT and IMDb system, I mentioned before. And the last one, implement of collecting, processing, and publication article information product automatically by the system. Yeah, this is IWIS Indonesia. Any participant know about IWIS Indonesia? What is IWIS Indonesia? Yeah. IWIS is nationally integrated electronic system which can be accessed via the internet public network, contains aeronautical data and information based on digital. Integrated IXM, integrated and IXM 5.1 format, guaranteed data security and interoperable with the system, like the NOV system, BMKG. BMKG is the Aviation Meteorological Agency Indonesia, and CVGHM, the agency provide the controlling about the volcanic ash, central volcanology, geology, hazard, and mitigation. This system, IWIS, interoperable with that system, which allow the exchange of aeronautical data and information, enable to collect, process, and publish aeronautical information product the system. The system also support to collaborative decision making for handling the impact volcanic ash for operation. Today, I do not talking about the CDMVA. We are focused in the IS2IM article data, because the system include for manage the collaboration decision making for handling the volcanic ash. Objective of IWIS, increase efficient safety through the provision of quality aeronautical data and information based on digital and integrated. The second one, provision of information system, support CDM process for handling the impact of volcanic ash for flight information, like the Pak Takata Sang said before, Indonesia manage the impact of the volcanic ash very well, and we hope the operation can be managed when the volcanic ash erupts. And the last one, compliance of IQ ISYM, hope compliance of IQ ISYM through the availability of digital data in IXM 5.1 format, integrated and interoperable. Benefit of AVIS for the quality warnings as a warning system for the impact of volcanic ash. CDM can manage the CDM and publication as well. Yeah, this is the system. IWIS, Indonesia Web-Based Aeronautical Information System Handling Portal, single submission of data and information, single and synchronized processing of data and information, display Indonesia IP in HTML and PDF format, and support to IXM format 5.1. And the second one has the e-chart, electronic chart, article chart, web-based and desktop application. This is the display about the IWIS, consists of regarding the electronic chart. Yeah, maybe we can see here. Yeah, here the display regarding the form of the article data about the IP in format HTML, PDF, and this is about the chart. This is the PDF, this is the IXM, and this is for the HTML. In IWIS can be displayed, can be processed the article data in this format. Yeah, this is how to create the IP product. This is a module for the IP submission. You know that this IWIS developed for the make easier data originator submit the data, because Indonesia is a larger area, many airport, small airport, many remote airport in Indonesia. So sometimes difficult to send or submit by manually, or we know when we do by manually to submit the data can be affect the some maybe for some data loss or something wrong and anything and etc. And that's why in the IWIS system, data originator can submit the article data information, submit the raw data online directly to the system. This is, this is for example how to a data originator submit the data which are changes, and this is the module. Yeah. The system also provide traceability, process traceability when some data, some publication, we have to know what happened in the data when published in, for example, one cycle. We can tracing in this module. Yeah, this is publication tracing by the bundle of the publication. For example, if we some data indicate something wrong, we can find out in the bundle of IEP amendment, and we can trace what are the error or what are the happen with the data. Yeah, I wish also provide a electronic chart like the sorry. Yeah. This is the chart provided by the IVs, like the aerodrome obstacle chart, instrument approach chart, star and SID. This create by the system, and this is the display. This is the form for the IS personnel checking all the pace of the, for example, is the EFP, and after that they have to manage and process in the desktop, because for the processing the charting electronic, they have to create in by the desktop, and after processing in desktop directly display in the IV system. Yeah, this is the IM planning program. We have established regulation. We have to establish regulation and related to the implementation of IS to IM. This is the important. This is the legal basis what we have to do. And the second one, complete and ensure the suitability of SOP, standard operating procedure. And capacity building, this is important. This is what I talk about, what are the global navigation plan guide for state in the four major, like the regulation, human, quality management system, and the system. This is the planning we have according to, we refer to the global navigation plan. Yeah, this is capacity building, and then formal arrangement, because so many entities in Indonesia, and then we have to improvement our system, especially for the IM, and the conduct continuous oversight. This is the important, because we have to evaluate what are the services, is it correct, is it comply with the regulation or not. Yeah. This is the last presentation. Time of implementation, collecting, processing, and publication aeronautical information product automatically by the system. This is the timeline for the, we have for the implementation, for the publication using the IV system, The first one, establish and revision some regulation that I mentioned before. We have still developed for the guideline. And then the second one, adoption of SOP. This is important for the Airnav Indonesia to adoption our guideline, our regulation to how to manage the publication. And then system improvement is continuously doing. And the fourth, regulations socialization. This is also important. And training of all IS personnel and data originator. And then trial operation publication using the system. And then shadow operation and the last one full operation by the 2025. We hope we have planned for this process, I-pay process, using the I-wish system by this year. I think that's all about our sharing regarding the plan challenges, what we are doing about how to implement article information management in Indonesia. Thank you.
Thank you, Mrs. Dina. Big applause. The floor is for Mrs. Viranti now to continue with just the presentation with regards to the implementation and challenges before going to the possible question session later. Floor of yours.
Thank you. Good afternoon, everyone. Good morning, everyone. I'm sorry. Hopefully, you're not getting bored after listening to the presentations, because we agreed to present all our materials, then discuss the topics together, because more or less our presentations are related to each other. So, okay. While Ibu Dina as a regulator present the regulations and the AIM transition change, and also how we're going to transit from AIS to AIM, I would like to, of course, we do share the same challenges with what Ibu Dina has presented. But currently, I want to share more about what we are doing right now in Aeronautical Indonesia and how we try to manage the challenges that we face while we are still in the process to transit from AIS to AIM. A brief overview of Aeronautical Indonesia. I think not all of you have known us very well. We've established on 12 September 2012, but actually we start operating in 2013. Previously, the air navigation service provision is provided by Angkasa Pura I and Angkasa Pura II, but starting 2012, Aeronautical Indonesia is established, and we are assigned to provide air traffic services, aeronautical telecommunication services, aeronautical information services, aeronautical meteorological services in collaboration with the Meteorological Office in Indonesia, and search and rescue information services also in collaboration with Search and Rescue Agency. And we have a vision to be the international standard air navigation service provider, so we keep improve our service despite all the challenges that we face. We believe that together with all the aviation stakeholders, we can move forward facing the challenges together with collaborative efforts. And yeah, mission is we provide navigation services that prioritize safety, flight efficiency, environmental friendliness, and in order to meet the expectations of service users. Of course, these missions also applies to the provision of aeronautical information services, which all of the users played a significant importance in how we do our service. We manage to provide air navigation in Jakarta FIR and Ujung Pandang FIR. We have 2 flight information centers, 2 ACCs, and we have approach control units, aerodrome control towers, flight information regions, and we also provide aeronautical services through 1 AIS center, 10 regional offices, and 1 international NOTAM office. We also provide flight procedure designs for 1 unit providing services for the whole Jakarta and Ujung Pandang FIRs. A brief overview of the traffic we serve from 2019 and then 2020, 2021, where we get the impact from the COVID-19 pandemic, and then the traffic is going up, and we're looking forward to more positive way for the traffic growth, and hopefully coming back to the presentation from the first day, that we are looking for to manage more bigger traffic management, and then how we can provide it in a more cost effectively. So yeah, we are the operator. What I want to show you, this is just one of the presentation from ICAO in the first day, mentioning about the IQ USWAP findings. One of the findings was about the regulatory oversight. And after that, we are certified under CISR Part 175. And then DGCA, I believe it is to comply with the IQ requirements. Almost we get audited or inspected a few times a year, I believe. So if you may ask one of our colleagues from AIS regions or International NOTAM office, we often get audited or inspected by DGCA inspectors. So don't worry. Hopefully we continue improving our compliance level. So brief overview about AIS Center in Airnav Indonesia. We have AIS headquarters. And then we also have AIS regional office spread out all over Indonesia. Then we have one NOTAM office providing the whole NOTAM services for Indonesia. And we also have chart and flight procedure design unit. AIS headquarters, the general task will collect raw data from the data source and we validate and then we publish. Actually, we submit to DGCA to publish the AIP. And then we do the registration, verification, classifying, and compose the draft. And we ensure process meet the quality requirements, and we also do the user feedback handling. For AIS regions, they collect raw data collections from data source. They do also register, verify, classify, and compose draft AIP and NOTAM. And they also ensure the process meet the quality requirement. They also do user feedback handling, and they do pre-flight and post-flight services. We will get into the more details in the next slides. And of course, for NOTAM office, NOTAM, ASTAMS, NOTAM, issuance and distribution, and also do the NOTAM exchange. For the chart and flight procedure designs, we collaborate with another entity in Airnav Indonesia. We compose instrument flight procedure designs, and we put it into the chart, and we also do the user feedback handling. Also keep ensuring the process meet the quality requirements. This is where our regional office is situated. We have one in Medan, we have one in Palembang, Jakarta, Surabaya, Denpasar, Balikpapan, Makassar, Manado, Sorong, Sentani. I understand that some states have only one AIS center, and they are dedicated to serve the whole state. But this is one of our one of our efforts to encourage more the participation of the data originators. That we understand that not all data originators understand how to submit their data correctly. So the regional office has more roles to interact more with them. So this position may benefit for the operational use. And we also, as the regulatory require us to implement the quality management system, and we are certified for the ISO certification. For the AIS process, the AIS headquarters and AIS regional office will, for the AIP and ISA publication process, headquarters and regional office will receive the raw data for publication, then we register and verification. You may ask why the HQ and the regional do the same thing. It is because we have different data originators. There are data originators for certain parts of the AIP that have to be submitted to the HQ, while for the aerodrome parts of the AIP, they should submit the draft of publication to the regional offices. Then both will do classification, drafting, validation. After it is validated and we submit it to DGCA, DGCA do the publication. And after it is published, the HQ and the regional office will do the post-publication evaluation for checking what the publish is in accordance with the raw data submitted. And for the NOTAM process, HQ and regional office will receive registration verification, classification, and draft the NOTAM, and then until the NOTAM office will do the distribution and then continue with the evaluation and evaluation after it is published. For the AIP and AIC production, first thing, data originator will submit raw data change request, and then if we do the registration and verification, if the verification not passed, we go back to the data originator, and if it is passed, we do for the classification and we do publication classification. If it is related to the IFP, we will send it through to the IFP team for the follow-up action. And if it is not, then we do for the AIP and AIC. All then will go through the quality control process. Then after that, validation. If it is passed, go to the DGCA for approval and publish. And after that, we do the evaluation for AIP and AIC. We identified the stakeholders in the data chain. We understand that that stakeholder data originators has a lot of impact in the quality of the AIP that we publish. So we identify the data. Our data originator is Aerodrome. I think it is almost the same like most of all of you. Airspace and procedure design, ATS provider, med service provider, CNS provider, SAR service provider, other state sources like Geographical Institute, equipment services, and etc. And for the AIS, state AIS, is we, along with the GCA, play this role, of AIS and also the GCA. And then downstream data production is for the data providers, and the end user will be airlines, pilots, drone users, and also flight briefing of other states. What we're doing currently with our data originators to ensure that we get what we need and the data originator get their data published according to what they need, we agreed on some formal arrangements. The service level agreement this is a sample of the service level agreements that we develop with the data originators from airports and also with the ATS unit within Airnav Indonesia. Along with inside with service level agreements, we define what we provide to them with what in a certain time period and what they should submit to us and when they should submit to us if they want it to be published in accordance with the schedule. And also, we include the data product specification, what they will need, how they should provide the data to us. And aside from that, we also require to develop a letter of operational coordination agreements with certain entities related to the data provision and coordination in the air navigation, in the aeronautical information service. For the aeronautical database management, you all have seen that DGCA has planned to implement the new automation system that currently being developed, and we already use it for the ASTAM services. But while waiting the acquiring process for that system, Airnav Indonesia IT team and also the experts in AIS team developed the tools for database management, where the AIP data tags are stored in Indonesian IAD, IAS database application, and for the GIS data are stored in NavEarth application. How we maintain the database is AIS headquarter and AIS region will input the published AIP amendment to the IAD. Then the AIS headquarter will check the data request that has been inputted by the AIS headquarter and the other team in the AIS region. If it is okay, then if it is past the quality control, then it will be checked as okay for being approved. When it is meets requirements, and it will be approved. If it is not, the data will be rejected, and then it will be stored in the AIP amendment stored in IAD. For NAVERT database, for the chart, after publication, the team will identify airspace change and then identify ITE's route change after publication also, and identify NAV8 change, and then after that will be inputted in the web page and or the GIS software, and then it will be stored in the centralized database, and it can be viewed in the NAVERT application. Plan and challenges, like I said before, we shared the same challenges that DGCA presented earlier. I just don't want to reiterate it again. But what we want to inform you is that another thing that we face is, along with the modernization of our ATM system, there are one automated aeronautical data processing system that the purpose is to supply the aeronautical data to ATM system. So the challenges that we face in transit to this system is about the legacy data migration, for chart data migration, familiarization, integration, and for data exchange. What we do right now is we try to convert the legacy to AXM data format, and we will do the chart digitation and convert it to GIS data. And we will do the new system familiarization, system integration to other aircraft system, and data exchange for SWIM implementation. This is the website that currently we use to provide some services and to manage our database. And I would like to inform you that this website is developed by the Airnav Indonesia IT team, and we have along with us the representative of the team. We have Dito over there as the AIS expert developing this, and we also have Om Udin, Mr. Udin, who also helped develop this AI center. And I would like to give my voice to Mr. Udin to explain each one of the box of this website. Please, Mr. Udin.
Thank you, Bu Vera. Maybe as Bu Vera explained previously, we developed some application to support the process of AIP publication, because we do it manually now using Microsoft Word, Adobe, and AutoCAD. So we developed some application to record the process using the EOS application that display and some form that required from the ISO process, ISO 9001 2015 for the process. And another application is to store the textual data is in EAD. The process is when the publication reach the date, we input manually to the database, and we store in the database and waiting for the effective date will be included in the database. And the next is for the note time management. We develop the Navigate application that inside the NAVKit there are some services, pre-flight briefing and post-flight briefing, and ASTAM viewer we provide in NAVKit application. And the next is the NAVCARD. NAVCARD is 5 LNC handling. So for the name of a point request or significant
2025 regulation socialization. How did you conduct this regulation socialization? This is my first question. The second one is the NAMP. How did you develop the NAMP? The NAMP, National Air Navigation. Okay. And for Ms. Vinatali,
IM, Article Information Management. So we can do, for example, make the sharing session, workshop, or training. What we develop about that system and about how to manage the article data information management process.
Thank you, Mrs. Gina.
Yeah.
I think that there is about the IWish relationship between IES Center and IWish.
Okay.
yes, about the two softwares or databases, how are they going to be integrated?
Yeah. Okay. Regarding the database, AirNav existing has database, article database for the produce the IP product, and GCAA developed the IWish for the manage and process the article database as well. And then the IWish system means that we have database use article data with the IXM format 5.1, and then we also developed two submission raw data online by the data originator. For example, for another airport in somewhere, example is in Papua, can submission directly by online into the IWish system. And for the next plan, yeah, we have to share with the AirNav. We have to review about the database, which one, and if it is whether the database can do integrate with our with IWish. If can do integrate, we can integrate, and we make the pace. We make the stage which one do by the system AirNav, and what we do, what has do with the by the IWish. We have to make some. We have to we have to comparison, and we have to make the share. I mean pass. The function. I mean the function. We have to make the which one the function using by the AirNav system, and what the function do by the IWish. I mean like that. Thank you.
Thank you very much for this answer. I think that time is up, or Mr. Hilal is still will. One question, yeah.
Yeah, it's about the quality.
Yes. Go.
Yeah, thank you, Mr. Hilal, for the question. We also agree that quality is an embedded process, even currently in the IIS being transitioned to AIM. Actually, part of our commitment to quality, that's one of the reasons why we developed the data quality requirement. So along with the DGCA to enforce from the beginning that we get the qualified data that we need to maintain the quality of our publication. I often joke that AIS Center is just publisher. So what you give us, if what you give us is good, then we can produce a good one. But if what the data originator provide us with not so good data, then maybe the quality of our publication may not be good. So how we embed the quality in our services, it is to start from the beginning. Of course, we do have the quality policy, we do have a certain SOPs, and we have a lot of checklists. While we do things manually, we have a lot of forms that have to be filled, and we have to do the correlation process manually. That's what we are trying to keep up with the quality standards. But first, there are so many of us here from the all stakeholders. We need collaborative efforts to ensure the quality of our publications, and we need every data originators to provide qualified data and also in a timely manner. So that's I can say. And anything to add about the integration of the IWISH. As an operator, we understand that the transition from AIS to AAM will need a collaborative effort again from the all stakeholders. So it is a good thing that the DGCA will lead us when transitioning to that, because DGCA has the authority to enforce the regulation and to make the regulation and to enforce them and to oversight.
Mr. Hilal, just to elaborate what if Ferranti said regarding how to manage the quality data. Yeah, of course, what we have to manage the quality data is coming. If Ferra said mentioned about the quality not only from conduct by the IS personnel. Data originator as well has to conduct the quality. So that's what in our regulation we state them to conduct the quality before they submit the data to the IS personnel. Then, like in our presentation, data originator make ensure the data quality before submitting to the IS personnel. Thank you.
Thank you. Last question from Mr. Sari.
Thank you very much. First of all, I'd like to say that I was really impressed by your presentation, which is well structured and shows a clear vision. And it's not possible to automate or digitalize what is not clear. You need to be clear before digitalization. That's what I saw. On your presentation, you mentioned the challenge, which is engagement of the stakeholders. So I'd like to know how you do it. A bit of coordinating, a bit of incentivizing. How do you do it?
Thank you, Mr. Farid, about your question. Regarding of course, we have to know, we have to understand about what we are digitalized and automatically. Correct, Pak Farid. In the IWISH system, the data is generated by database, digitalized, and the data process is automatically. I mean that when the data coming, data change coming to the data originator, and then the system can be processed automatically For example, when the data in POR in the part for some airport, POR located in the part aerodrome and in the part en route as well. So when the data change in the submit by the data originator, all the part consist the POR located automatically changes by the system. I mean like that for the processing in the IVS. And for the second one about how to engage the stakeholder to implement the IM, yeah, this is the challenges we face in the large area, large and so many entities in Indonesia. Yeah, we have to conduct some like the workshop, like the focus group discussion, and we have to sharing, make the, for example, sharing session. I mean, explain how what we have to do, what state responsible about some issue like IS to IM. I mean like that. Maybe Ibu Vera can elaborate about how to engage the stakeholder.
Yeah, engaging a stakeholder is quite challenging, of course, Mr. Farid, as you may have known. We cannot do it in one day workshop like this, but mostly we try to get more people involved in a discussion about AIS and like this one. And then when DGCA, also the DGCA has some what do you call, regional offices also, right? In the airports, airport authority, when they have an agenda for the socialization or workshop with the airports or aviation stakeholders all around them, they tend to involve, or we try to engage with the regional office to get involved in that activity. And it needs continuous efforts and discussions with everybody, and then to make people understand. And then the challenge is when we have already good collaboration with one entity, and then the person that we make contact with move to another place, then we have to start all over again. But that's what we have to do continuously. So it is not once a year or one time activity, but it's a continuous progress, I think.
Thank you. Thank you so much. The time is up, so I won't ask if there is any other question. I think that DGCA, Airnav, and Indonesia deserve a big applause from all of you. Great presentation, great presentation. And words to Mr. MC.
Okay, thank you very much, Mr. Muhammad Ali, for facilitating the discussion. Thank you very much to all the speakers, to Ms. Dina Yunita, and also Ms. Ferranti. Thank you very much. That was a very insightful presentation. You may return to your seat. All right, ladies and gentlemen, now we will have 15 minutes break. So you are welcome to enjoy the coffee and tea break. And don't forget that we will be back with the next session in the next 15 minutes. And also, I would like to remind you one more time, maybe anyone here just join us. If you hear the angklung sound, yeah, something like that. Just like Mbak Caca did just now. You can get back to your seat immediately because we're going to continue the session, the next session, which will be the session for Mr. Farid Zizi and also Mr. Louis Zirut. So please, ladies and gentlemen, enjoy the coffee break, and we will be back at 15 minutes. Thank you very much. for this session. The first is Mr. Farid Zizi as the Administrator and Executive Director of FRAX. Please come to the stage. Mr. Farid Zizi will be accompanied by Mr. Louis Zirut as an air navigation expert of CGX Aero. Farid and Louis will talk about the use of digital data, airspace design, nav aids, obstacle assessment. And for the second topic, our speaker would be Mr. Manuel Rabalia as a senior procedure designer of CGX Aero. He will share about proposed impact on flight procedures and challenges. And to please welcome Mr. Manuel Rabalia. And to facilitate this session, I will call the moderator for this session, Mr. Muhammad Ali Megales. Please come to the stage and facilitate the discussion.
Hello everyone again. So here is the second session of this morning. Let us immediately welcome Mr. Farid Zizi for the airspace design and obstacle assessment stuff with Mr. Loic Giraud. Farid, the floor is yours.
Thank you very much, Mohammed. Good morning, everybody. Today it's a day for exchanging practical experience of use of different, I called it geo and AIS data, whatever application. And that's what I will try to do, and I understand that Loic will more focus on obstacle limitation surfaces and detection. So, I will go relatively quick. I made the choice to have a number of slides, so you will have the presentation afterward. No, so don't be too much afraid by the fact that I'm going quickly. So the first part, I will discuss a bit airspace design in two different projects. I remember you the principle of our Diadem platform we presented yesterday. And the first project I want to mention is the project we have with ASECNA on Lomé Airport. What does happen in Africa presently? They are developing SBAS, and this may be of interest to Indonesia because it's SBAS in the tropical area where you have some ionospheric phenomena, which makes it a bit more difficult than in the northern hemisphere, in Europe or in the United States, where you have equivalent programs. And what ASECNA wanted was to demonstrate the environmental benefit of having SBAS, because presently you have an ILS on the QFU 22 and nothing on the QFU 04, which means that very often aircrafts are obliged to go on the QFU 22 even with adverse meteorological conditions. They developed, they developed RNP procedures, which is not yet published. And then what they asked me to do, me or our team to do, was to compute the environmental benefit of having that infrastructure available. So what we did, very simple, we were taking all traffic sample arriving on QFU 22. We did develop the mirroring trajectories, and then we measured the environment. So I show you what it is. You have an Ethiopian coming from Addis Abeba, QFU 22. That's the real trajectory. We developed the opposite trajectory, And then what happened is that we, for all aircrafts that are arriving to Lomé, we measured the environmental benefit. What was interesting is that when you have a unitary benefit, when you multiply by the quantity of flights coming from, for example, from Accra or from Abidjan, you really see the global benefit of having the use of the QFU-04. And this is really interesting because usually if you ask one aircraft, they would never say, okay, I want to land on the 04, except if it is coming from Accra. But when you see the global benefit, then you see the benefit of having this facility available. So I will not enter in the numbers, but you see, it's hundreds of tons of fuel which are saved in simply having those facilities available, and it's a clear argumentation for ASECNA to develop that type of facility. The next project I want to show you, I will go quickly, but first I will launch a video. For those who are speaking Spanish, listen. For those who are not speaking Spanish, read.
Bogotá, ciudad capital de Colombia, tercera capital más grande del mundo, culminando a 2.640 metros de altitud. Su aeropuerto internacional El Dorado es el principal de la región y del país. Es también uno de los aeropuertos más importantes de América Latina. Su tráfico aéreo, administrado por Aerocivil, es uno de los más densos de la región y podría duplicarse todavía en los próximos 20 años, alcanzando no menos de 180 aviones por hora en picos de tráfico y entre 70 y 100 millones de pasajeros al año. Un desafío importante para este aeropuerto con solo 2 pistas hoy en día, insuficientes para manejar este crecimiento. Hay una necesidad de pensar de nuevo las infraestructuras de tierra y la gestión del espacio aéreo del TMA de Bogotá. Un segundo aeropuerto y nuevas pistas, por supuesto, pero ¿cómo? 3, 4, 5 pistas paralelas, perpendiculares a las pistas actuales. ¿Cuáles serían los criterios de análisis y de viabilidad? Y sobre todo, ¿para qué beneficios y resultados esperados? El sistema aeroportuario actual y su futura evolución presentan desafíos de concepción y de realizaciones técnicas y operativas en un medio ambiente con características geográficas y estructuras complejas. Seleccionados en un concurso público en 2019, Frax y su equipo de expertos han trabajado varios meses a analizar 20 escenarios operativos posibles para responder a este desafío. No menos de 18 expertos multidisciplinares de la aviación civil francesa y de CGXAEO, empresa asociada, se han movilizado en torno a Frax con la ayuda de 2 socios locales para desarrollar de este modo competencias complementarias y ampliadas al beneficio de este estudio. ¿Qué metodología de análisis? Un método estructurado y ágil, 7 criterios principales considerados y una calificación de cada uno de estos criterios dentro de una matriz analítica que permite una selección por fases incrementales de escenarios más eficientes. Al final, un escenario vencedor, respondiendo de manera óptima a la mayoría de los criterios de eficiencia y de pertinencia para el TMA de Bogotá. ¿Qué solución preconizada por el equipo de Frax? 2 aeropuertos de proximidad, un sistema de 4 pistas independientes alimentadas por 4 PMS para una distribución óptima de los aviones en las pistas y una gestión segura y efectiva de los despegues y aterrizajes. Condicionado por procedimientos RNPAR para el aeropuerto El Dorado 1, que son necesarios a la coexistencia de 2 aeropuertos en este espacio limitado. Esta solución permite, además, una gestión óptima del tráfico y un impacto controlado del medio ambiente. El Dorado 1 acogería entonces aviones equipados RNPAR y modernos. El Dorado 2 acogería todo tipo de aeronave, comerciales, militares, cargos. Bogotá y Colombia podrían así responder a su reto de crecimiento del tráfico y convertirse en actor clave de las últimas innovaciones aeronáuticas mundiales en América Latina.
So, what is important there? Why did I choose this project? First of all, we did compare 20 scenarios. In those scenarios, if you don't have legitimate GIS or AIS data, you are lost. The second thing, which is important, is that at the end you want something to be implemented, and one condition of making it possible was to have RNP AR at the end, so procedure design that was developed by CGX. And what you will see also is that I will not go in the details of the project, but the first things we had to do was to estimate all the constraints. As you perhaps understood from the video, Colombia, Bogota is a very difficult environment with a lot of mountains around, so obstacles. The city is not far, and for example, when you take off from the runway, the mountains is not so far in front of you, so you have a number of constraints. And in this area, they wanted to build a second airport. And of course, you don't have much place there, which means that the separations between the two airports were really a challenge. So we have evaluated the different scenarios, and finally we found a solution, which was to specialize one airport to RNPAR and having the second one with conventional procedures. And of course, we had to clearly delimitate the boundaries of the two areas. We finished with that sort of map, spaghetti map, and thanks to Loic, when I had to demonstrate the benefit of our projects, he did develop a map with different layers, a digital map, where I was capable to push on a different star, depending the QFUs, to demonstrate what we had developed. So you see it. On top of it, of course, you see it, it's perhaps not so obvious to look at, but during 6 months of the year, you have thunderstorms there. So the thunderstorms are there, the military area is there. Where do you have place for aircrafts? So this was another challenge. And of course, being capable to compute all the data, to put the aircrafts and trajectories, to simulate them, was a real asset. The problem is that at that time we didn't have yet Diadem, and it's after that project that we developed the platform I showed yesterday. We were capable to assess the traffic capacity and change the sectorization, and we were also, thanks to the data another time, be capable to assess the noise from 2018 compared to the forecasted traffic 2029. And what I was saying yesterday, for the neighborhood, you need the geodata of the buildings, you need the geodata of the population, you need all that sort of data. So it's another use of the data, and you put your traffic on top of it, you measure the noise, you map the noise. It's another way of using everything. At the end, the question was, how do we develop? And then we referred to the GANP I presented the first day in discussing all the functionalities and capabilities they had to develop to make it possible. Don't forget, the challenge was you can only have a second airport if the trajectory are separated, and it means for the first one to become RNPAR, which is a real challenge. So I wanted to show you this project because this project is having everything in one package as a problem and challenges. And everywhere you have data, everywhere you have AIS to AIM challenges, everywhere you have procedure design. And this is really a good example of what could become aviation. The project finished 2020, and then COVID arrived, and of course the traffic forecast did change a bit. But this is it. Now, what I want to show you is something else than airspace design, and a few examples of using the data in different activities. The first one is drone usage for calibration activities. You would ask me, but why do you speak data when you just want to calibrate a PAPI or whatever with a drone? The question is very simple. When you want to fly a drone on an aerodrome, very often your client, even if you neutralize the runway during that time, will ask you to have a flight plan for your drone. You cannot develop the flight plan if you don't have the data on the aerodrome and the obstacles, a number of things. So this is a very simple activity, but you still need the data. That's just what I wanted to say. And of course, if you do ILS calibration, your drone, with drones even, your drone is going far away. You also have to do a safety study where you will be capable to demonstrate the level of risk you create to the neighborhood or to different areas of the aerodrome. And of course, for that, another time, you will need the data, and the IMDb may be of very good use there. Safe and see. Mohammed did mention it. This was about automatic trajectory generation in case of emergency. The purpose of the project was very simple. You are a pilot, my friend from ATR. He's in an emergency. You lose power in your engines or whatever typical problem you have. You don't have the capacity to land where you want it. And then we have to offer an alternative solution to the pilot. The purpose of the project was to offer 3 solutions to the pilot, and the pilot to decide. Of course, you have to avoid the terrain. You have to have the weather information. You have to have, I would not say aeronautical information, but information on the landing place, because it can be something else than an airport, and you have to upload that to the aircraft. That was the challenge, and we finished with that, and this was a really big, challenging demonstrator for this AIS to AIM, and I would add weather and geographical data management, and that's the reason I wanted to show you this project. Another thing we are working today on is autonomous driving vehicles. I'm not speaking flying drones, just autonomous driving vehicles. And there, the question is, for example, for luggage, for runway inspection use, for different usage, is what do you need to make it happen in a crowded airport or even a non-crowded airport? The first things you need is to have your driving vehicle know the platform, to drive automatically from one place to the other. How do you know the platform on an airport like Charles de Gaulle, for example, where you have work on the taxiways and the runways every day, every night? the geography is changing, which means that you will need a well-designed map. This map shall be uploaded to the driving vehicle fleet management system. Then you have to have what I call the flight plan for the drone. Now I call it a mission plan, but because it's not a flight, but it's the same. And you need also to be capable to share the intentions of the vehicles on the platform to avoid collision. And of course, if it is slippery, if there is some danger or whatever, you need to have that sort of information. Even the work who showed that, I think it was Anaël, to show almost accident on the runway because people were working there. But if you have a blind autonomous vehicle on the runway or the taxiway, you have the same risks and hazards. Last example, and this will also introduce the presentation from Loïc, is what we call in France Aeronautical easement plan. In that case, it was in Cameroon. I did put obstacle limitation surface, just I'm not sure that you use easement plans in Indonesia, but it's more or less the same purpose. To define what is problematic in the various obstacles around the airport or in the vicinity of the airport. You do it for various reasons. First of all is terrain obstacles. The second reason are also your all your facilities, be it nav 8, be it when you have frequency, you need to compute the frequency coverage. When you have radar, you need to compute your radar coverage. You need more or less to have a sort of electromagnetic protection of all your facilities around the airport. And so that's what we call easement plan. And you need also to have it for the lighting, because if you have, Javier yesterday night showed us a runway with a big building at the end of the runway. And of course, whatever you put as a facilitation or a mean on the runway, if you put that sort of building, it will hinder the lighting, it will hinder the electromagnetic propagation, whatever. What I liked in Mrs. Dina's presentation is that there is a process there. I loved it, because the problem is not really the building, it's the process before building the building. But it's clearly something where you need data, you need to record data, you need to update data, you need to process data, and not only for detecting obstacles. You need it for all the facilities that you developed around the aerodrome, and more than the aerodrome, the airspace, to make it possible to fly there. So this is an example in Cameroon, but of course you have to do it on all airports of the world. And like what we described before, and like most probably Loïc will describe, you need a process there, because what you see on a one day may change on the second day, and your easement plan may be positive at some day and become negative if you don't manage the data and the various users of buildings and obstacles around. I am finished. Thank you very much, and I will pass the floor to Loïc.
Thank you, Farid. So yes, as mentioned by Farid, implementing the obstacle limitation surfaces is then another duty and a daily challenge. Usually, in many countries, when you have obstacle limitation surfaces in place, you also have a protocol, you have a process. For anybody that is willing to create a new building, there is a request to be sent to the airport or the civil aviation or the ANSP, no matter. And this request will be analyzed by the different body of the aviation professional, flight procedure designer, OLS expert, CNS expert maybe, and at the end you will get a feedback. Now the idea is that if we have digital data and if we are able to share those digital information into, let's say, a human understandable way, why not sharing this information with non-aviation experts? How to provide to, let's say, regular people, people that are dealing with construction, people that are dealing with other topics than aviation, the good information and the necessary information to be able to capture the aeronautical constraints. So this is one of the examples that we would like to show you here. Again, thanks to the aeronautical digitalization, you can, and the example of AirNav is a very good one. They created the Nav Earth platform to share the information, not in AXM5. Again, AXM5 is a mean. It's not the final target. The final target is to make this information available for the most possible people. Doing this, you can have on any background that you can imagine. It can be a web platform, it can be a web services. You can share the limitation constraints of an airport with something that is very easy to understand. In this case, we are on a French airport, Bordeaux. You have two different runways. You can see here the impact of the OLS surfaces, takeoff, landing surfaces. You have the inner horizontal, and here the different circles, or here the half circle at the end of the runway, are the CNS facilities, protecting the VOR, protecting the localizer, protecting the glide path, protecting all the different navettes of the airport. So if you provide this in such a way, this is of course one way to do it, not the only one. Anybody that is willing to create a building here will get a detailed information on what are the available elevation. If now this map, this data are created by certified people, approved by the CA, now you have something on which you can rely and on people can rely to make their plan. And you will not receive, let's say, so many information and so many requests for building construction because you share the information the way people are expecting it. Same here, we make the computation now subtracting from the maximum altitude the terrain elevation provided by the airport. And now it's even more easier for the people that want to create building. Usually, when we receive at CGX a request for a building, people don't really care about the top elevation or stuff like that. They say, no, I want to build a 5-floor building, 10-floor building. This is what they are challenging for them, how many floors they will be able to develop. If you provide them with height values instead of altitude, they know directly 30 meters, 10 floor. 15 meters, 5 floor. And then after, they can decide if it's worth to invest on this location or not. So this was just the first example. Another example, and actually it comes from a question I really have a lot in my daily work. It's, well, we need to invest and we need to spend a lot of money on implementing ETOD. That's fine. But what would I do with ETOD? Why? I don't need ETOD. If you remember again on the day 4, think again that the investment you will make on ETOD or anything is not directly for the return of investment on you. It's also for the benefit of the other. Now imagine that you have this ETOD survey, most especially on terrain information. What can you do with such a terrain? Manuel will describe with way more precision the application for procedure design. But I just wanted to highlight one or two interesting cases we had in the past. I would like to welcome you in Bosnia. Bosnia-Herzegovina is a very small country of Central Europe, surrounded by very high mountains. And unfortunately, we have some airport right in the middle of the mountains. And of course, we have people that want to land there. So we had to develop a conventional procedure. The challenge was not on the procedure themselves, but we had some safety altitudes defined by the terrain and defined by the pencils. So we have the regulatory margins, we had all the compliance with the 8168, everything you can imagine. But then at the end, we show the result and we show the draft of the charts to pilots, to people that are actually flying there. And they said, no guys, you're 10,000 feet here, you could not achieve it here on this waypoint. We cannot receive the Mike Sierra Romeo VOR DME. It's not possible. We have a jamming issue, or we have a masking issue actually. We said, well, no, it's not possible. We did everything. We have all the computations. So we talked with some people from the CNS department there, and because they were lacking this kind of information and digital data, they were not able to help us. So we decided to perform the coverage computation, and actually the coverage computation shows that here there was a lack indeed of guidance from this VOR here at the center on this line here. The blue line is the 9,000 feet coverage. That was the altitude requested at just the beginning of the DME arc, and the purple area is the 10,000 feet. So there is a gap here. Fortunately, we were able to detect it again on a collaborative way. It was not only CGX. Everything came from the pilot there, and then after for all the people involved. But thanks to the digital data that we had, we were able to simulate this coverage, and eventually, before the implementation of the procedure, we were able to change the altitude here to flight level 120, and also to change the guidance request using a VOR that was on the northeast. Of course, at the end, this was submitted to approval to the CAA with a specific request and a specific care during the flight check, that the flight check team should carefully check if the coverage was fair enough. Imagine doing this without the same information, or without the same tool, or without the same things. We would have implemented a procedure that could be dangerous. We could have implemented a procedure with this kind of issue. We should have waited for the flight check to raise the point, then come back to the study, then come back to the check, and so on and so on, and we would have wasted a couple of weeks, even months. Another interesting topic when you are in mountainous environments, sometimes you cannot implement traditional trajectories. Farid highlighted this with Bogota. For Bogota, if you remember, for one of the airports, it was not possible to implement traditional trajectories. So we decided to implement RNPER. Here in Mostar, it is the same. So it is the same airport. Not one issue, but several issues there. This runway end, the runway 15, was not accessible with traditional means. The mountain was too close, so VOR approach is not working, ILS is not working. We don't have enough distance to ensure a straight final and a straight intermediate segment. So we had to go for curved approach and RNPER. The thing is, on this case, with RNP 0.3, the minima are here on the first straight line. That means all the remaining part of the final in RNP 0.3 should be visual. But what is visual? That means the pilot should be able to see the threshold, or let's say the runway, all along the visual segment. He should not miss the visual on the runway. And then we had an issue, and again, thanks to a pilot feedback, they say, we might not have the visuals on the runway. So we had to try to assess it and to demonstrate or to quantify actually the time during which the pilot will not have visuals, and then anticipate what could be the safety measure to put in place on board to face this situation. So thanks again to all the digital data that we had, shared by the civil aviation, shared by the airport, shared by everybody, we were able to make this small simulation. So we are along the track, and we have simulated the pilot's eyes, looking at the runway, looking at the threshold, trying to catch up this runway all along the track. And here what it is. You see here? So for a couple of seconds, the pilot is losing contact with the runway and losing contact with the threshold. So this was an issue that, again, were able to be discovered during the design process. So we had a couple of time and a lot of discussion with the airlines, with the airport manager, with all the different people saying, okay, now, is it acceptable or not? What could we implement to mitigate this risk? Part of the answer was to reduce the RNPR tolerance. So we went from RNP 0.3 down to RNP 0.1. With this, we were able to avoid some of the obstacles and have the minima on the just close to the final rollout point. But still, for the people that are not able to fly RNP 0.1, we have some specific mitigation, and there is a specific briefing in the simulator before the flight for this kind of topic. Again, imagine doing this without digital data or without coordination between the shareholders. It would not work. So we would have discovered this during the flight check, and imagine the impact then on the implementation of this procedure. With this, we, let's say, nearly not lose any time. And then after, as mentioned, so this have been detected during the design phase. It was documented and checked during the ground validation phase, and we asked for specific flight validation activities related to this topic. Again, we didn't invent anything. ICAO has documented all you need to make a good things. It's just at which point you discover such issues. So again, thank you for your attention. We will welcome some of the questions. Just for today, our idea was to make this final day as a kind of demonstration on what to do with those data. We talk a lot about implementing the things, implementing AXM, implementing data, implementing a lot of information. And we wanted to conclude this workshop with what to do with it. It's nice to implement things, but it's even better to use what you implement.
Thank you, Loic. Thank you, Farid and Loic, for this interesting, very interesting feedback about operational use case and real use cases. So the floor is for you for any question. No question about the challenging? So probably while waiting for a question, I might just add one or 2 points, because my colleagues, they came back to operational cases and certain very challenging cases where the digitalization supported the resolution or the detection of possible really a hazard, possible major risks if ever we implement such procedures, for example, which can be dangerous. Just to insist on 2 aspects is that automation is very good. There is 2 other points or 3 other points that needed, that operator need to be really well informed and in a very good, let's say, knowledge of the risk of the hazard that their job might bring. Second is that all the detections and all the computation have been done because the data was trustable. That means the data was of the very good accuracy, and was shared by the different stakeholders and so on in order to develop the good data, the good information on top of it. Because if we start on garbage data or whatever, for example, if the digital terrain model was not good in Mostar and so on, we could not have seen that simulated that we are losing the visual with the runway. And the third point is that for all the automations, there is one aspect which is a major aspect with regards to the ADQ and so on, for example, in Europe, and which Pansayam also is looking for, is the validation of the tools and the automations, the algorithms which are used. There is something which is called DSU, the Document of Suitability of Usage, that might be provided, in fact, by the manufacturer or the team who is developing tools and so on, to show the compliance, the full compliance to all the ISO 9001, all the level of, or the expected level of quality assurance in terms of verification, validation, specification, testing, and so on. So there is, if you automate something, pay attention that you are completely documenting it, and pay attention that you are maintaining it at the very correct level, because if you make automation, you are becoming dependent of the algorithm. And if you are becoming dependent of these algorithms, you need to maintain their qualifications themselves. Any question there? Okay. So as we are, Javier.
Okay, first, thank you very much for the very interesting presentation. I don't have a question. I would just like to do some sharing, because I already been working on procedure development. And from my experience, concerning the issues that could have an impact on your development that can be discovered late, normally in procedure development, we are going to be checking the terrain awareness system, that there is no alarms, okay, during the approach or during the takeoff, or when you use this procedure, right? What I have seen in my experience is that need to be careful when you do this in the flight, in the simulator phase, because in many cases I identified that the database that you were using, or the system in the simulator, because the simulator normally is a training tool, right? And they were, in a function point of view, they were realistic. Then for the pilot training, were very adapted. It was their basic function initially. They were developed for that. But when you use them for procedure testing, if they are not using the appropriate database, you will be seeing wrong information. Like, I have the example, I used a simulator that was not updated the database. We were using an old one, and we were having alarms where there are really no alarms. Because if you update the database to the correct standard, they were the good ones. And I have another case that was different. In that case, I had also alarms that I shouldn't have. But in fact, what I discovered is that this simulator, to ease, I would say, the development of the simulator, it has been decided, instead of implementing the real database used on the aircraft, they were using just the visual database. Then the visual database was as used as those databases. That for training purposes was fine, because they defined the exercises that work properly, and the pilots have the alarm when they are doing the exercises. That was fine. But when you are testing a procedure, basically you are testing your procedure with a dummy database. It's something that is just for training. It's not an operational. Then you could do all your development, have checked on your simulator, everything is fine. You arrive, first flight, toes alarm. Then it was just sharing my experience on this type of development that I had.
Thank you very much, Javier. And you're right highlighting this point. I think we already addressed also it during one of the previous days, closing the gap between, let's say, the ANSP, AIS world with the airlines, data integrator world. This is one of the next challenge that we have to do. Such is design development, but you're right to stress on that. And again, the answer to this, coordination, data sharing, trust between the different stakeholders, and you can solve all the technical issues.
Thank you. Thank you, Loic. Thank you, Javier. So now the floor is for Mr. Manuel Rabaglia. It is an excellent transition with regards to flight procedure design stuff and so on. So, and Manuel is going to talk about this, I hope.
Thank you very much. Good morning, everybody, again. So it's nearly 12, and they send me on the floor talking about procedure design. So let's try this challenge. So we have seen a lot of things during all this week about ETOD. So now we know that we may get reliable database in terms of terrain and obstacle. And we have procedure designers who want to use this data in their daily job. So ETOD addresses all phases of flight. I will only focus on the SID, arrival and approach. But en route part is considered by ETOD as well, because there is area 1. And we talk already about some emergency that may occur during the en route, but it's not the topic of this presentation. So area 1 address all the states. Okay, we see it a lot of time. And for a procedure designer, after the en route phase, we have to protect our aircraft in what we call arrival. So for our arrival, we need a lot of data, but we are far away from the airport, so we don't need that much precision. So for this type of job, it could be an arrival, it could be a minimum sector altitude, or TAA, terminal arrival altitude, whatever. It's not the topic to talk about that now. It's just to address the fact that is this nice area or weird area for normal people, it's nice only for procedure designer, huh? But is this weird areas covered or not by ETOD? So of course, if you have area 1 and area 2 in terms of obstacle and in terms of terrain, you will be capable to cover that requirement at, it's a rough value. Here it's a small airport in middle of a very nice country. And it's a simple procedure, but even a simple procedure, you see that you need to be at 45 nautical miles. Yes, it's mass, but it's 45 nautical miles from your RP. So this means that area 2 is not enough. You need area 1 as well when you are protecting your this type of arrival. So if you have a full ETOD implemented, you are capable to get all the data you need, and you have a green light. You can, a procedure designer may do his job. No problem about that. So arrival, done. So let's talk now of the approach. Approach from initial approach fix to final approach fix. Sorry for that, but just to be a little bit precise. So from the entry of TMA to the beginning of descent, to tell it faster. Here, you may see that the protection area is still weird, always. No. We have the initial segment, intermediate segment, and eventually, if there is any need, we have an holding before to initiate the approach. So in this case, once again, if we compare this to what we need, it's more or less 45 kilometers. Not exactly. You see there is some light blue circle of the holding, what we call the buffer, but are not inside that. And that is just for a small airport, small procedure, very basic one, of course. So 45 kilometers, you may see that it's a value here. It's the latest limit for the area 2D. So don't be surprised if your procedure designer sometimes may ask you, it's not enough. 2D is not enough, I need more, because I go after that. But, of course, if you have your area 1 and area 2, you are capable to protect your initial and intermediate. It will not be green light during all the presentation. Huh? If it was green, I make just one slide and it will be enough. Let's talk about approach. Let's talk about approach. So, more complicated protection area. Here we are at the approach. We are at that part, that we call that waypoint. We go until the runway. Here we initiate the missed approach before the runway because we have terrain in front of us. Procedure designer may say, I take easy case, I'm over the water. But it's just for the topic of the presentation, to not show you something too much complicated like that. We see the protection area. And the main point is not really there. In fact, ETOD provide data for the area 2 until 10 kilometers, as we see on the red circle. And basic one could be area 2A and area 2B. But 10 kilometers for procedure designer, that's not enough. That's not enough, unfortunately. Because if you look the violet area 2B here, you see that we stop even before the point. And most of the time, procedure designer need more than the point. And if you look on the edge here, you see that if we just consider area 2B, a part is missing. And of course, when we initiate the missed approach with play, so in that case, 2B is not enough as well. So you realize very easily that for a procedure designer, if you don't provide the 2D and the 2C, he will need, like say, a complement. Maybe he don't need to get the 2D until the 45 or the 2C until the 10 kilometers on the side. But he need more, obviously. And, that's why if you have unfortunately your air traffic control tower there, even if you have the feeling to be far away, like with play, we strike into the tower, and that's an impact on the mill. It's another subject. So here we see a lot of time this picture. So we are in the area 2B. It's a slope of 1.2%. Like that, looks nice. 1.2%. It's very low slope. But even on the side, it's 1.2% slope coming from the edge of the runway 3. And when we are in area 2D, it's obstacle more than 100 meters. Okay. We have seen this theory a lot of time. But now, if we try to apply that inside an approach with lateral navigation. So this means the aircraft have no vertical guidance. Aircraft is on the green trajectory. Final approach, 3 degrees. And in red, we see the protection here. So on the paper, like that, maybe we are covered. But no, there is no vertical guidance. Like there is no vertical guidance, light green is not nice, but procedure designer need to know all obstacle here. All obstacle above that. So if we just consider ETOD, there is missing part. So this not mean that the procedure designer cannot do his job, but this means that artificially he will have to take conservative measure. So if you provide just ETOD to procedure designer, he say, okay, it's better than nothing. I can do my job with that. But in that case, maybe I have to put a step-down fix on the final. In that case, there is an obstacle. So it could be a very good reason to put a step-down fix. But if there is nothing, and if there is no survey of that part, procedure designer, he still has to put a step-down fix because he doesn't have the knowledge. He doesn't have the knowledge of obstacle at the beginning of the final. Same here for the intermediate part, or maybe the end of the final. He has to consider that there is 100 obstacles by default. If there is no over data. So for this type of procedure, it's a good beginning, let's say, but it's not the paradise. We are complicated people. That's why I put orange light, to be optimist. Okay? So now let's see with vertical guidance. Vertical guidance. So if you have a vertical guidance here, you want to know all your obstacles in this area to make it simple. In that case, oops, sorry, I go too fast. In that case, like you have a vertical guidance, you can ignore obstacle at the beginning of your descent. And that's the strength of the vertical guidance in Barrow-Venaf procedure. So this means that for Barrow-Venaf procedure, you can face to a situation more easily if you don't need to collect your terrain, or your obstacle at the beginning of the final. And same, if we continue here, it's Barrow-Venaf. If we have a glance to the ILS procedure, you see that here we have the final guidance. Beginning of descent is there, the runway is there, and here in gray you have the area to be. So it's a concept. It's not every time the case, but for here, you see that, oh, it's like a coincidence. It's fitting. So of course, if you are procedure designer and you have ETOD, for ILS procedure, it's perfect. It's perfect. But as soon as you have the missed approach, we play. And as soon as we play, we need this complement. Or the area to see, it could be rich. But if we take an airport in middle of a city, and if we have a limited budget, maybe we cannot go to take all the buildings on the side. We just need a complement here, something that will come in complement of an ETOD to help us to finish the job. So that's why sometimes the airport manager, they are surprised. They said, oh, we have ETOD. And procedure designers say, we want more. That's why. Okay. We have the green light, especially for the approach 3D final. If we have all the area 2, it will be good to do the job. So I go very fast on that. That part is what we call circling. So of course, circling, the purpose is to go on the side of the runway. So here it's obvious that you need area 2C. But here it's Bangkok airport. You see that even the area 2C will cover nearly perfectly the violet circling. So in that case, of course, it's good. Let's talk about departure. The way we define ETOD area, it's we initiate the area to be at the end of the runway or at the end of the runway strip or at the end of the clearway if there is existing clearway, and we climb 1.2%. So for a type alpha chart, it's perfect. It's exactly the definition of the type alpha. But for departure, here we have a PBN departure, so we take off from that runway, we are on the red line. You see that the area to be, it's good, but here on the side, we have once again missing area. It's not missing if you have area 2C, okay? Don't misunderstand me. But if you have only 2A and 2B, it will be not enough. We need a little bit more. So in terms of 3D, it's perfect because the slope is 1.2%. Procedure designer minimum procedure design gradient is 3.3%. So this means the orange one here is at 2.5%. So of course, here it's very good. So if we have a full area 2 or let's say, a complement if you cannot provide the 2C, 2D, ETOD will be good. On this, green light, orange light, doesn't change what I said on Tuesday. ETOD is is a real plus for the procedure designer when you need to analyze the obstacle. I will not come back on that. So let's talk about omnidirectional departure. So you see that if you have two phases to omnidirectional departure, the area to be in violet will be a little bit small if you have to deal with this type of area. So in that case, same 2D, 2C. It's always the same, or at least a part of it. Few words about some attributes, and you will understand why we spend time on that topic earlier. Imagine you have to protect a departure, so the green area, and in the past, before ETOD, you have an obstacle, an apex here, and this obstacle is defined just by X, Y, Z. So obviously, for the procedure designer, here, no penetration. But here, if this obstacle is a building, we just have the apex of this. We have seen that with ETOD, we can define by, let's say, a complex way, a complex building, or we can modelize this complex building, taking into account all the accuracy of the measure. And, for example, we can define this complex like a cylinder. If we know the geometry of the obstacle, even if the apex is outside our protection area, we may get a corner little bit lower, but inside the protection area. On that, it's a quick draw, but in the real life, that arrived. It's not just a concept, that really arrived. So about metadata, same. Procedure designer, double check his viewer, he see a monument. Oh, there is nice clock. He look in the metadata and he see clock tower. Wow, okay. You see, it's if we want detail about obstacle, using all our tools, thanks to the metadata, thanks to the attributes of the data by itself, we are capable to find information. Here, for example, a small building. We have a small building, and like I said previously, I'm capable, if I want more information, I know who measure it, when he measure it, and who is the data source. I can go deeply in the detail as much as I want, and like that, I feel confident on my job, and I can perform a safer task. So, to conclude, ETOD is not enough for procedure designer from some part of the job. For some procedure, because I skip all the conventional procedure for this presentation, I'll just take into account the PBN one. For some type of procedure, and especially for procedure without vertical guidance, we need a complement of area to get all the information. So that's why, in this case, if this need is identified, it could be taken into account like a specific case, and the data originator will be aware that for this case, the covered area to data collect will be a little bit wider. I will skip that, and before the question, a little quiz to wake up. Paggy, Paggy, Paggy. Amazing. Sorry. So, like the other time, you will get 6 questions. Superman is back. We will find you, Superman.
We have a lot of people, that's great. More and more and more.
Allez, let's go. Let's launch it. So ETOD address all phases. Oh, nice. All phases of. Sorry. ETOD address all phases of flight. Yes or no? That's not complicated. 61 people. Wow. Bon, I will take the yes. Yes, ETOD address all the phase of flight. All. You have to cover from the taxiing, the takeoff, the SID, en route phase. We address all the phase of flight with ETOD. Areas 2A and 2B cover enough to protect final approaches without vertical guidance. That's a bit more complex than the first time. Very good. No. It's not enough. We need to see, if the final is, 10 kilometers, 5 nautical miles, it's I forget it, 9620 meters, something like that. So 10 kilometers, most of the time it's not enough. Departures protection area needs area 2C and 2D. Don't listen him.
The crew is here.
How we will share the price if everybody win? How we will do? Chacha will, yeah. Yes, of course it's yes. Thank you, Loïc. Geometries of line and polygon could be important in procedure design. If a procedure designer may see the geometry of obstacle, that could help. I have a bad kid in my back. Yes, it's important. It's important. More we have detail on the obstacle, and more we are capable to perform complex protection areas and computation. Metadata are irrelevant for procedure designer. So yes, no, maybe. You have no maybe paper. Yes. The good correct answer was no. Very good. Once again, when you click on an obstacle, more you can read about it. Is curriculum vitae, better it is. Next, ETOD will be a real plus for procedure designer needs. It's the last question, so that's why it's an obvious one. I cannot shortcut if not everybody answer. But yes, it was just to finish this presentation. Of course, it's a real plus for procedure designer.
Great,
So
great.
thank you very much. Let's see if Superman win. No. Oh. You may boo, 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 boo. So not consider the first line. So who is Lima Whiskey? Again? No.
Yeah.
Thank you, Leila.
Okay.
Thank you very much. So congratulations, Leah, for to win again.
Again. No, other again. So thank you, Manuel, for this presentation and this animation also. Thank you, Loic, for making the Krona. Was good. So hopefully we can have a few questions if there is any. We still have 5 minutes to go for questions, so feel free. Regarding procedure, adjustment, needs, is it sufficient for ETOT or whatever? Everybody is hungry, I guess, right? So, if no question is there, we can stop and go just with Mr. MC, Mrs. MC.
Mr.
Okay, thank you very much to all the speakers. Can we please give big round of applause for the 3 speakers and our moderator for today. Thank you very much. You may return to your seat. Thank you. That was really insightful. Okay. All right, ladies and gentlemen, after this, we will have lunch break. And please get back to your table at 13:20. Yeah, after that, we're going to continue to the next session. So yeah, enjoy the lunch. So hopefully you enjoy the last day of our workshop, and this is gonna be our lunch together. Yeah, our last lunch together. So please enjoy, ladies and gentlemen. Don't forget to come back at 13:20. You will hear the sound of angklung from Mbak Caca, yeah, when the time is ready. Thank you very much, and I'll see you on the next session. Have a good lunch, everyone. Thank you.
Mas Hendik, monitor Mas Hendik.
Suaranya masuk.
Mas Hendik dengar suaraku?
Dengar.
Mas Hendik monitor. Dengar gak?
Suaranya dengar. Coba tes aja. Satu, dua, tiga.
Mas Hendik monitor Mas Hendik. Masuk Mas Hendik.
Oke. Satu dengar masuk.
2. Tapi dari sini belum masuk ya? Kebanyakan Mas. Sebentar Mas. Ini belum masuk ke belum masuk ke ini, ke ballroom. Bentar.
Oh, oke, tinggal baru. Ini orang engineer-nya tak suruh ke sini. Siapa tahu ngatur feedback-nya.
Nah sekarang gimana Mas? Coba ngomong Mas.
Oke, cek 1, 2, 3. Tes. Orang engineering ya, saya suruh ke sini ya, biar ngontrol nanti kalau ada feedback atau apa. Ya. Dan selama sampai ini aja, waktu Microsoft ini.
Mas ngomong terus Mas, bentar belum masuk ini suaranya.
Oke, belum masuk. Oh itu tuh orangnya yang baju pink. Kayaknya itu. Oh bukan ya? Tanpa tak panggil ke mana ya? Tes 1, 2, 3.
Coba ngomong Mas.
Masih lama Pak?
Gimana Mas? Udah masuk belum? Masih belum. Mas Hendik monitor, coba ngomong.
Terus minta dikontrol audionya supaya nanti nggak feedback atau apa ya. Oke, udah masuk belum? Belum ya? Tes 1, 2, 3. Tes 1, 2, 3. Tes 1, 2, 3.
Gimana Mas? Coba ngomong yang besar Mas.
Udah 1, 2, 3. 1, 2, 3. Nggak putus-putus kan? Global player in. Hah? Aman? Belum. Ini aku nyuruh orang hotel sih di situ supaya supaya ngontrol audionya. Ada di suara tapi tes 1, 2, 3. Tes 1, 2, 3. Tes 1, 2, 3. Coba. Belum masuk? Belum masuk?
Oke, gedungnya kecil Mas kayaknya Mas. Oh gitu ya. Iya soalnya ini kecil. Belum. Tadi aku dengar cuma kecil banget nih. Iya ya. Kecil suara kesini. Iya. Iya, speakernya tadi
kalau belum datang atau pas lagi makan siang ya. Tapi suaramu jelas di sini. Tinggal yang di outnya aja ya. Berarti kan aman kan?
try first. Yes. Yeah. We try with team, with Jill. And the idea is that I will do like a very brief introduction of myself and what we're going to present, and then give the floor to Jill. I was thinking of that.
Audio. Ya, mic-nya kurang. Yang matikan aja, Mas. Aku yang bikin suara. Itu orang hacking-nya udah datang. Udah. Cek, cek. Tes 1, 2, 3. Ya, bisa. Tuh.
Mas Hendik, monitor.
Iya. Gimana?
Enggak, ini Mas Hendik monitor. Jelas ya, ini ya. Nah, Mas ini sambil ngomong ya, biar kita cek audio level gedung nih. Gak apa-apa, ngitung aja 1 sampai sejuta, Mas. Ya udah, bentar Mas, bentar. Iya. Ya, oke Mas, nih, coba terus ngomong ya. Mas, ini aja videonya video depan. Oh. Ngitung Mas, 1 sampai sejuta lumayan loh.
1, 2, 3, 4. 1, 2, 3, 4. Cek, cek. 1, 2. Belum ya? 1, 2. Cek, cek. 1, 2, 3. 1, 2, 3. Masih belum. Dan 1, 2. Oh, sinyalku kesini semakin hilang. Dan. Ini kayaknya sinyalku nih. Oke, 1, 2, 3. 1, 2, 3. 1, 2, 3. Aku pakai koneksi. Oh ya. Oke, 1, 2, 3. Gimana? Kurang? Masih kurang. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oke
Harusnya
Mas,
baca
udah masuk.
novelnya si Dika ini.
Mas Edi udah masuk nih.
Oh udah.
Udah masuk ke rekening belum?
Masih di gedungnya gimana, aman?
Oke, udah nih, coba Mas Indik masuk ya. Depan
Oke,
pintu,
1,
depan
2,
pintu.
3. 1, 2, 3. Aku masuk ya.
Ya, depan
Oke,
pintu.
1. Tes. Ini bagus ini. Cuman agak mendem sedikit.
Iya, itu feedback,
Oke.
mungkin agak feedback gitu.
Iya. Makanya aku harus keluar.
Oke, berarti udah aman ya.
Iya.
Ya, nanti
Oke,
tinggal
sip.
sama
Makasih, Pak, ya.
narsumnya kita cek lagi.
Ya. Nanti habis ini kan ini minta stand aja. Nanti begitu selesai. Takutnya kalau ada feedback atau bantuin.
Okay, good afternoon, ladies and gentlemen. Welcome back to Asia Pacific Workshop on Digital Aeronautical Transformation. Now we are coming to the very end segment of our workshop of all. So please get yourself ready, nail it. This is the last segment, not the last session, but the last segment, yeah, after lunch. Before going to workshop, let me remind you again, 40 minutes presentation followed by 20 minutes Q&A session. We are really welcome to receive your questions by raising your hands. And also, we are also receive paper, yeah. If you want to ask in bahasa, please just write down your questions in the paper and then give it to our committee. Boleh silakan di kasih ya buat teman-teman yang Bapak dan Ibu sekalian yang mau bertanya dengan bahasa Indonesia, nanti boleh kertasnya dikasihkan ke Mbak Caca untuk ditranslasikan ke panitia dan disampaikan ke panelis. Itulah tadi pengumuman sekilas. And on the next session we will have speakers, of course, our qualified speakers that will talk the topic about. Okay, I'm gonna call the speakers for today. Maybe we can see the picture first.
Good afternoon from Toulouse.
Okay.
Gilles speaking from ATR, Flight Operation Support in ATR. Good afternoon.
Mr. Gilles, let me introduce you first, and then after that we will get back to you. Okay, so our first speaker is Mr. Gilles Gracier. He's a Flight Operations Support Manager at ATR. That will be more introduced by our next speaker. Yeah, so Mr. Gilles will be assisted by Mr. Javier Serra Paler, Head of Technical Support and Regional Flight Safety Manager. So Mr. Javier holds a master's degree in aeronautics from the INEC, French Civil Aviation School, and a master's degree in computer science from UPC Barcelona Tech. He joined ATR in 2009 and occupied different positions in the fields of aircraft performance, software development, flight operations, technical support and safety in both engineering and customer support department. And since 2019, he is based in Singapore and currently working as the head of technical support and regional safety manager in charge of the Asia Pacific region. He also holds a private pilot license. So please welcome on the stage Mr. Javier. And the next speaker, yeah, I believe you all already know him. So just welcome him with a big round of applause, Mr. Louis Ziru, as an air navigation expert of CGX Aero. Okay, and this session will be moderated by Mr. Louis. So, Mr. Louis, time is yours.
Makasih. So this is the short final of our workshop. I hope you still have some energy for this afternoon. We will have a very, very interesting presentation from our friends from ATR. Please really open your eyes, open your ears, because you will get the feedback and the opinion of your final customer. As AIS department, as people involved in the air traffic control, the publication, your final customer are eventually the airlines, the pilots that will fly your procedure, use your data, and we thought it was very interesting to have a feedback from them on how they use those information. So we asked for a specific focus, of course, related to ETOD, AMDB. So you will see how ATR is using those information for both flight operation, but also inside the avionics. Gilles, can you hear us?
Yes, I hear you.
Perfect. So
good afternoon.
The floor is yours. Good morning for you.
Yeah, thank you, thank you. Okay, good afternoon for everybody. Do you hear me now? It's okay?
Perfect.
Okay. Good afternoon. My name is Gilles Granchet. I work for the Flight Operations Support in ATR in Toulouse. And the presentation is about the end user, so the airline, and the point of the manufacturer about the use of the terrain database, obstacle database, and airport database. So I will share my presentation. Okay, so let's see the presentation about the terrain and obstacle database for the end user. So for the point of view of the manufacturer of the aircraft, so ATR, and the airlines, in fact. So first, a short introduction about the use of obstacle and terrain database. Then we will see all the main phase of flight where the obstacle database are very important to ensure the safety margin, and so takeoff, landing, and en route with the drift down. So at the end, on chapter 5, we will see the obstacle database and the terrain database in the avionics of the aircraft. And we will finish with the conclusion on this presentation. And after that, of course, if you have any question, don't hesitate. We are here to answer to all your questions. So about the introduction, so the terrain and obstacle has to be taken into account for all the phases of flights. So from takeoff, climb, during the cruise, and at destination for landing, plus the missed approach. So for all this phase of flight, so we need to have an obstacle clearance, which is defined by the regulation, the different regulations. So mainly EASA and FAA. So this clearance, we assume that we have an engine failure. So an engine failure during takeoff, or en route, or for landing. And so we need to have a safety margin with the obstacle with only one engine operating. So now we will see the different phases, the most important phases of flight, and what about the obstacle concern on this phase of flight. So the first one is the takeoff phase. So the takeoff phase is the most critical phase of flight, and so we have to take into account the engine failure during this phase. So we have to take into account all the obstacles in the takeoff funnel. So for takeoff, the takeoff weight can be limited. So it can be limited by the structure of the aircraft, so the maximum takeoff weight, or it can be limited by the runway. So, for example, for takeoff on the short runway, you can be limited by the climb gradient, because the regulation requires to have a minimum climb gradient after takeoff in case of an engine failure. And finally, you can be limited by the obstacles which are located in the takeoff funnel. So we determine the limitation of the takeoff weight depending of the environmental conditions, so temperature, wind, runway surface. And so after the computation of the limitation, so we determine a takeoff limitation weight and the associated takeoff speeds. So we have to take into account all the obstacles in the takeoff funnel. And so by regulation, we need to have a safety margin in case of an engine failure during takeoff. So for that, first, so we have the gross flight path. The gross flight path is the path flown by the aircraft. But to have a safety margin, we have to determine the net flight path. So by regulation, the gross flight path has a penalty to determine a net flight path. And this penalty is 0.8, minus 0.8% from the gross flight path. So you determine like that a net flight path. And so you need, by regulation, to have a safety margin between the obstacle and the net flight path. So here, in the takeoff funnel, so you need to have a margin with the net flight path of 35 feet if it's a straight-in departure, or if it's turning departure, so the margin should be more than 50 feet. So to determine all the obstacles in the takeoff funnel, so the regulation determine an area to see all the obstacles. So we have a specific corridor, lateral area, where all the obstacles must be cleared with a regulatory margin. So there is a specific corridor for each regulation, so for EASA, so European regulation, and American regulation. So if we see the corridor in the, so there is some detail about that. It's not necessary to go to the detail. So if you see the takeoff funnel in the 3 dimension, is like that, okay? So with a beginning of the corridor on the runway, after that extension of the corridor with the distance, and so we have to determine all the obstacles in this area. So you can find the obstacle on the takeoff funnel on the AIP, so the Airport Information Publication. So for this example, so it's an AIP, and you see here you have the takeoff funnel determined according to the European regulation or American regulation, and inside this corridor, so you have all the obstacles. So the obstacles are expressed in 8 and the distance from the runway. But sometimes, especially for the regional aviation, so like runway, VFR runway, visual runway, with no IFR procedure, and so there is no information about the obstacles. So in that case, so we have to do an obstacle survey to determine all the obstacles in the takeoff funnel. So sometimes the obstacles are very limited for the takeoff weight, and so to avoid this obstacle, we can study turning departure like that. So after takeoff, so for example here, to avoid the obstacle in the mountain, if you fly straight ahead, so we turning right to avoid the obstacle, and we determine a new corridor. After that, so with the terrain and obstacle database, we determine all the obstacles in the flight path, and then we compute the limitation for takeoff. So in this case, so we determine a list of obstacles expressed with the distance from the takeoff run available on the runway, the distance, and the height of the obstacle. And then we compute the limitation. So in ATR, we have a software for that, which is the FOSS, Flight Operation Software. And so with this software, we take into account the obstacle to determine the takeoff limitation. So an example on the ATR 42600, the maximum takeoff weight of this aircraft is 18,600 kilograms, the structural limitation. The example of today on this runway, for a temperature of 30 degrees centigrade and 10 knots headwind, so we have a limitation, so 30 degrees, 10 knots headwind, so we have a limitation of 16,407 kilograms. So you see, here you are limited by obstacle, the code 4, limitation by obstacle. So this is the 4 takeoff for the chapter 2. Now for landing. So same as takeoff, so you can have some landing weight limitation. So the landing performance has to be assessed prior to takeoff for dispatch of the aircraft to determine the limitation for the flight. And the landing performance can be reassessed during the flight if it's required by regulation. So for landing, the limitation can be due to the structure, so the maximum landing weight, so the braking energy, the runway, or short runway, and the minimum go-around climb gradient, which depends of the external conditions, so atmospheric condition. But of course, if you have if a mountain or obstacle surrounded the airport, of course, you need to have a safety margin with the obstacles, so the minimum climb gradient will increase. So the result of the landing performance study, so you determine the landing limitation weight and the associated speed, so approach speed and go-around speeds. So if you have an en route failure, for example, a failure with the flaps and so on, so of course, so for all the time, so you have to take into account the engine failure. But if you have another failure like the flaps, for example, you have to reassess the landing performance during the flights. So for the approach climb gradient, so one point about the regulation. So by regulation, so we need to have a minimum climb gradient. So per certification of the aircraft is 2.1%. But the operational requirement, so the minimum climb gradient for operational point of view, so it's 2.5. So on the approach chart, so if you have no information of the approach climb gradient, so it's 2.5 in fact. So this climb gradient can be read on the approach chart, and this minimum climb gradient is 2.5, but it can be more due to obstacle surrounding the airport. You have another requirement from the regulation is to have a minimum climb gradient of 3.2 in landing configuration. So with all engine operative, but here it's 3.2%, but it's never limiting on ATR. So the main concern is the approach climb gradient. So the approach climb gradient is from the decision 8, so minimaz, and it's considered with one engine out, go around power, landing gear retracted, and flaps in approach configuration. So the approach climb gradient is at minimum 2.5% according to the operational regulation. But of course, if you have obstacle surrounding the airport, like that, of course, on the approach chart, you will have a steeper gradient. And so you need to have a margin with all the obstacles in case of go around. So, to avoid to have a huge limitation on the landing weight, so we have two possibilities in fact. So the first one is to avoid the obstacle, so to change, so to design another procedure to avoid the obstacle, or to increase the DH, so to have a higher minimaz in fact. So it's negative for the accessibility of the airport in case of bad weather, but you have less penalty on the landing weight. So with a higher DH, you recover the gradient of 2.5 with the safety margin with the obstacle. So so this is an example of an airport with many obstacles and terrain surrounding the airport. So here the go-round climb gradient is 370 feet per nautical miles, corresponding to a climb gradient of 6.1% due to obstacles surrounding the airport. So this procedure is designed according to ICAO Doc 8168 concepts. And so the possibility to improve the performance on this airport, and we will see after. But here you have a huge go-round climb gradient, and so with a huge limitation. So for example, on the ATR 72-600, the maximum landing weight is 20,350 kilograms, structural limitation. But on this case, if we take the temperature of 32 degrees in the wind can, okay, so we have a limitation of 16,275 kilograms, so which is very important limitation due to the approach climb gradient of 6.1%. So now, how can we improve this landing weight? So two possibilities. So higher decision 8 to recover the 2.5%, but you have less accessibility on the airport, or to avoid the obstacles. So for that, to avoid the obstacle, we have to redesign the procedure with a new go-around flight path. So this is the flight path according to the PANSOX criteria, which is 6.1%. And then we can redesign the go-around procedure with a so in this one, so with the PANSOX criteria at 6.1, the regulatory landing weight is 16,275 kilograms. If we redesign the go-around procedure with a new flight path, with a procedure of RNPAR, so we can avoid, with this procedure, we can avoid all the obstacles, and we can recover a climb gradient of 2.5%. And for the limitation with 2.5%, it is completely different. Now you have the regulatory landing weight at 20,927 kilograms. So again, of more than 4,652 kilograms. So it's a huge payload improvement due to redesign of the go-around procedure. To finish with the takeoff and landing, so in case you don't have any information on the airport, so we have to do an obstacle survey on this airport, and this is an example of an obstacle survey on the Tioman airport in Indonesia. With the terrain database, we determine all the obstacles on the takeoff funnel and the approach to determine the limitation of the aircraft. The terrain database is not sufficient, but we have to do on-site obstacle survey to determine all the artificial and natural obstacles like vegetation, for example, trees on the takeoff funnel or in approach, and also to artificial obstacles like antennas. And so after that, we enter all the obstacles in the software to determine the limitations for takeoff and landing. So this is for landing. Now let's see the en route limitation. So especially for flights over the mountainous area. We have to take into account an engine failure during cruise, and also a pressurization failure during cruise. And so with this kind of failure, we need to have all the time a safety margin with the obstacle. So in case of an engine failure, of course, the remaining power is not sufficient to maintain the flight level, and so the crew has to decide to descend to a flight level adapted to the single engine operation. So this flight level can be an impact on the takeoff weight. You have to determine perhaps en route critical points and en route alternate airports. So same as the takeoff, here first you have to determine the net ceiling. So the net ceiling first you have the gross flight path. The gross flight path, after an engine failure, the gross flight path is the path flown by the aircraft. And like for takeoff, we have a net flight path with a gradient penalty, which is here 1.1%, and the net flight path take into account the aircraft performance degradation and the pilot's average skill. So the net flight path is equal to the gross flight path minus the gradient penalty, which is 1.1%. And so you have to determine the safety margin with this net flight path. So same as takeoff, so we have to determine all the obstacles in the corridor. So this corridor is different from EASA and FAA. So for EASA, it's 5 or 10 nautical miles from the intended track. So 5 or 10 depending of the accuracy of the navigation. And for FAA is 5 statutory miles from the intended track. So now you have to, with this net setting, this net flight path, you have to determine the safety margin. So by regulation, the net flight path, the net ceiling should be above, the margin should be 1,000 feet on the highest obstacle en route. This is the requirement from the regulation, 1,000 feet above the obstacle for the net ceiling. So this is the condition 1. If this condition 1 is not met, for example, the net ceiling here is below the obstacle, so you can study with the condition 2 and use the down rules. So in fact, you can have the possibility to have to comply with a margin of 2,000 feet during the descent in the net flight path. Of course, in this procedure, you have to determine critical point. So before, if you have a failure, engine failure before this critical point, so you have to return back to the departure airport, and if you have a failure after this critical point, you can continue the flight to destination. So let's see an example of a study performed in Morocco from Casablanca to Ouarzazate. So a flight over the Atlas mountain. So first time we determine the flight path from Casablanca to Ouarzazate, and with the corridor of 5 nautical miles from the center line, we determine all the obstacles to take into account during this flight path. And so we obtain, like that, a vertical profile with all the obstacles in the corridor. After that, we enter the obstacles in the software to determine the limitation and to determine if we have the safety margin with all the obstacles. So we enter the most limited obstacle in the software, like that. And for one condition of temperature, wind, and so on, we determine the critical point here, decision point here and here, to have a safety margin here of 2,000 feet during descent. So we obtain two decision points. So that means that if you have a failure, an engine failure before this decision point, we have to return back to departure airport. If we have a failure after the second decision point, we have to continue to destination. And if we have a failure between the two decision points, okay, so here you can do what you want, to return back to departure airport or to go back to destination. So if we put the vertical profile, so we obtain the safety margin like that with 2,000 feet. So the last chapter is about obstacle data, terrain data, and airport data in the avionics of the aircraft. So the first one, we use the airport data and the obstacle and terrain data on the synthetic visual system. So synthetic visual system is to improve the crew situation awareness for the pilot on the primary flight display. So here you have an example on the primary flight display of ATR with the synthetic visual system off and on. With this one, which is the airport database with the runway, and here the terrain database. So this is the first avionics system who use the terrain database. The second one, which is an option on the ATR, is the synthetic visual system on enhanced flight visual system, EFVS. So the EFVS is a system to increase the visualization of the airport in case of bad weather. So for that we use cameras on the radome of the aircraft. It's night cameras and infrared cameras to improve the visualization on the runway in bad weather condition. So for that, the pilot, the captain, has a head-mounting display. So with all the information on the flight, like that. So here you have just the information, so altitude, speed, and the attitude of the aircraft. After that, if you put the enhanced vision system, you see more, you have a best visualization on the runway during the night and during if you have bad weather. Concerning the obstacle and terrain database, you can have also the information of synthetic vision system. So here, it's the terrain database coupled with the information of the flights. So like that. So it's completely synthetic information here with the terrain database. And we have the possibility to combine the cameras, so the enhanced vision system, with the synthetic vision system, and we obtain information like that on the head-mounted display. So information of the terrain database plus the visual information of the runway. So the terrain database is used also on the system, which is the terrain awareness warning system, TOWS. So it's a system which triggers some alerts in the cockpit in case if the aircraft has a conflict with the terrain. So on the navigation display, you have information like that of terrain. So, for example, the aircraft is flying towards the mountain, and at one moment, if you reach a certain limit, you have some alert like that, avoid terrain, to advise the pilot that there is a conflict with the obstacle. If the flight continue like that, so you have some change of color and alert. So to advise the pilot to climb immediately to avoid the terrain. So the performance of the aircraft is taken into account to have a safety margin with the obstacle in case this alert is triggered. If the performance of the aircraft is not compliant with the obstacle and the safety margin, so we have this kind of we have this kind of alert, avoid terrain. So in that case, the pilot has to avoid the terrain by left or right turn. So this is the system to avoid to trigger some alert in case of conflict with the terrain. In option also on the ATR, so we have airport navigation database. So we have the possibility to visualize the movement on the aircraft on the airport. It's especially used on the huge airport where there is many taxiways, and so if the pilots are not familiar with this kind of airports. To finish the presentation, so the terrain database are also used in the simulator visual system. So on the simulator visual system, so we have two different kind of visualization of airport. So we have a generic airport or specific airport. So the airport database and terrain database are used for the simulator visual. So for the generic airport, so is suitable for IFR training. So providing the real, so latitude and longitude, heading, elevation of the airport, and all the navettes of this airport. We also have a generic terminal, apron, and taxiway. But it's possible to have a specific airport. So in the specific airport, it's the real environment of the airport with all the building, the roads, the terrain surrounding the airport, and so on. And so this specific airport are used to train the pilots in the environment of this airport. So you can do some IFR flight, of course, but also some visual approach on this airport. So that's all for avionics. So in conclusion of my presentation, so the first one, this is very important. So the obstacle has to be taken into account for all the phase of flight. So takeoff, landing, en route, and so on. So the obstacle data are obtained from the airport information publication or on the specific software, so the geographic mapping software. But sometimes there is no data on the airport. And so we have to do obstacle survey to determine all the obstacles and to determine the limitation for takeoff and landing. Of course, for all the study, the engine failure is taken into account. And we need to have a safety margin with all the obstacles. So for flight preparation, so there is some gradient penalty to determine the flight path, and the safety margin has to be considered with this net flight path, safety margin from net flight path and the obstacle. And of course, for this study, to have this margin with the obstacle, this can induce a weight reduction, takeoff weight reduction or landing weight reduction. So that's all for my presentation. Thank you for your attention. And so now, if you have any question, don't hesitate. We are here for that. Thank you.
Thank you very much, Gilles. Then, as Gilles has introduced, you can see that the data is key for the aircraft operation, and this was the main message that we want to transmit on this presentation, and that this data in this region is even more key because our aircraft is operating in remote area. As you may know, one of the main challenges we face as aircraft manufacturer is to obtain this data, to perform calculations, to see if the aircraft can operate in these airports and is economically suitable for the operations there. Then it's very important that you work on your in the different countries, of the authorities of the different countries, to work on develop this new data, make it available for the airlines and the manufacturers. Any questions on?
Yes, we have a question here in the middle.
Yes.
I'm Rahmat Swandi from Pelita Air. Right now we have 4 aircraft ATR 72-500 and 1 aircraft ATR 42-500. I want to ask you regarding what adjustment and modification to the ATR performance calculation are possible if the aircraft take off in high terrain condition with a runway slope exceeding 2%, and how about the safety margin, for example, in the Ruteng Airport? That's all.
Then you are asking, if I understand correctly, what you can do in case of high temperature, right? And in case also of your runway slope is higher, runway slope, we agree, of 2%, okay? Then by default, ATR is certified on 2% runway slope, but you have also a modification that can be installed to go up to 4.5% of runway slope. And this one, after you need also to see your authority to get an operational approval to use, to operate on the runway. And there are some limitations associated in terms of wind limitation on the operation and some systems also. But this is provided, and I can share you more detail later if you want on this, this modification. And concerning high temperature operations, when you are have a performance limitation, then in that case, in general, the situation is that you are thermodynamically limited. What you can do in the 72, that option is not available in the 42, is to use the boost option. You can install a boost option that allows you to increase the maximum temperature that the engine is working, then delivering you more power, right? This, however, has a cost associated in terms of maintenance, and you need also to consider, because as you allow the engine to go at higher temperature, then you will have a little more maintenance to perform, okay? The cycles will be increased. This can be installed if you have 127 mic engine. If you have Fox installed on your aircraft, you can upgrade to mic. And for the 42, today there is no boost option. What you will have tomorrow is that we are working on a new aircraft version that is called STOL, short takeoff and landing. It will be the 42. There we will, you will have the ATR 72 horsepower installed on the 42. Okay, and there are other slight modifications on the aircraft, on aerodynamics to compensate in case of engine failure. But you have, you will have in the future this option, but only for new aircraft. This will be not possible, of course, to retrofit. It's a new aircraft. Does answer your question?
Thank you, Javier.
Terima kasih.
Terima kasih.
We have another question here at the front, please. So we have 10 minutes ahead of us, so we have plenty of time.
Yes, next question.
Thank you, Mr. Javier, Mr. Gillis, for the interesting and informative presentation. My question is about the RMP AR. What are the requirements for this kind of approach from air operator perspective and ANSP perspective? And what's the best gradient rate that you can reach in, you know, mountainous and terrain area?
As Jill is the specialist on PBN, I think it's better Jill to answer.
Yes, okay. So first, so it's especially on the, so the RNPAR is only for, today is for 72 and 42 600. And so, of course, you need to have the option on the aircraft. Okay, so you have two possibilities of option. So you have the RNPAR 0.31. So that means that 0.3, the corridor is, the accuracy is 0.3 during approach, 0.3 nautical miles during approach, and 1 nautical miles on the ground. And we have also the option RNPAR 0.3, 0.3. So 0.3 during go round. So for that, we have to modify the aircraft, and with the option, we have to put inertial system on the aircraft, IRS. So with the RNPAR, it depends of course, of the obstacles surrounding the airport, but we have a narrow corridor during a go-around, for example, or during departure, and so we can have a specific flight path with the RNPAR, with the curve trajectory, and so we can avoid many of the obstacles. And so by avoiding the obstacle, so of course we can improve the takeoff weight because of you avoid the obstacle in the takeoff funnel, but also you can improve the landing weight because you avoid the obstacle during go around. So you have to have a specific equipment on the aircraft, and after that, of course, you need to have the approval from the authorities to perform this kind of procedure. So we have a process for that, and so ATR and CGX also can help you to obtain this approval from your authorities, and that permits to have a best payload for the operation on the airport. And also the RNPAR, so you have also a possibility to have a best accessibility of the terrain, because you can avoid the terrain during approach, and you can descend with best minimize. So you improve also the accessibility of the airport.
Thank you, Gilles, for this very detailed feedback.
Thank you.
At this point, yes,
Thank you.
This is something very important to emphasize. RNPAR is not a magical solution. It's not because you create an RNPAR trajectory that you will solve all your problems instantly. I just would like to recall before the AR, the initial, let's say, acronym for this was SAR, Special Aircraft Aircrew Authorization Required. Then it has just been summarized as authorization required, but the previous one was more, let's say, readable. You need to have an aircraft equipped. That means you have some cost to invest on the aircraft and retrofit to mate on the avionic or to purchase brand new system. Air crew as well. It's not any pilot. It's not any crew that can fly to an RNPAR trajectory. If it is a standard one, then you have a minimum requirements to have, but if it is a very special one with deviation from the ICAO regulation that are authorized, that should be mitigated, it's even worth in terms of training, maintenance of the crew capacity. So again, as for anything, I think in aviation, it's a very close coordination to have between your airlines, what they can do, financially speaking, technically speaking, in terms of resource management speaking, what the CAA is able to do, or the ANSP, and it's really a trade-off to find. So if you have everything in front, financial is okay, technical is okay, human resource is okay, then yes, you can go for RNPAR. If one of these points maybe is suffering from some lack or not covering all the requirements of AR, just be careful.
Yeah, thank you very much. And it's important the points I mentioned, because there is some countries develop, for example, PBM procedures in general, not only RNPAR, but after if the airlines are not financially able to install the equipment, or they struggle to get the PBN authorization from the local authority because the airline is not able to build the dossier needed for this, or the local authority has difficulties also on approving and going through this process because it's long and takes time, then need to consider all these challenges. It's not just as said, we put the procedure, let's go, let's fly. But sometimes we put the procedure and nobody's flying it or nobody's using it. And then it's a shame we are spending resources and time without optimizing on the real needs that we have in the region or by our airlines. Even though said that in ATR, in a safety point of view, We want to promote all the instrumental approach, meaning that we want to move from visual to instrumental because we consider that this is a way to go to be safer in operations. But also we know that install ground equipment is very expensive, and in remote areas it's not worth it. We are not going to install an ELS on a remote airport in the middle of Indonesia on a small island where there is 2 flights per week or even less. But today with the new technology like PBN with the GPS, it's possible to create procedures at a much reduced cost and to maintain them, even though there is work to do. We cannot create them and forget them. I suppose that you already mentioned probably these days that there is a maintenance to do on all these instrumental approaches, even the GPS ones. And all these things need to be considered, but we encourage the airlines and the authorities to develop all these instrumental procedures.
Do we have some additional question in the audience?
More questions? Then if there is no more questions, before ending our part on ATR side, I would like to thank AirNav and CGX to organizing this workshop that I think has been very interesting for the community here in the region. Okay, I would like also to thank ATR operators that joined here today to the workshop, and of course all of the participants joining this interesting workshop that we have shared experience between professionals in aviation. Thank you very much.
Thank you, Javier. Thank you, Gilles.
Thank you. Thank you.
Merci, Gilles.
Thank you, everybody. So this was the last technical presentation. We are running out of time, and the last presentation that was expected, somehow Airnav did it this morning. It was how to present and to promote the aeronautical information in a different way, through web platform, through digital means, but actually you did already everything. So that's perfect. You save us some time. I think MC, that's wrap up time.
Okay, thank you very much to the speakers, Mr. Gilles Gourache, and also Mr. Javier, Mr. Louis Zirut. Thank you very much for your session. That was the first session of this segment. And now, ladies and gentlemen, we will have 15 minutes break. You can enjoy the coffee and tea break. And after this, we will have another session. So if you still remember, on the second day, Mr. Wasanchai delivered his presentation virtually, but unfortunately we had some technicality issue. So today, now he came right away, all the way from Thailand. Thank you very much, Mr. Wasanchai, to come to meet you personally and deliver his presentation. So can we please give applause to him? So ladies and gentlemen, let's have a break for 15 minutes, and after that we will meet Mr. Wasanchai for the next session. Thank you very much. Enjoy the coffee break.
university, academics, and research partner, both in Thailand and outside. And here you can see like ENAC is French. So I was one of the alumni of, from Toulouse, so that's why we work together so far. Okay. So before it was a portfolio, but I want to be quick. Just give you a very practical, easy implementation of digital transformation, how it's going on in my country. Looking back in 2015, 16 in Thailand, we got one important major finding from ICAO. There were missiles everywhere in the country. The pilots always report. If you know any Thai pilots, you can talk to them. Do you know bang fai? What is bang fai? And they will say, oh, it's I've seen bang fai many times in my life, something like that. So what it is something like this. This is called talai. In the northeastern part of Thailand, local people, they believe that they launched something like this to ask from the god for the rain to come, because it's very dry in the dry season in Thailand. And they were like, let's say 30 or 40,000 of these kind of things in 2 months in the northeastern part of Thailand. The below one is a rocket. It's very common. Every 1 minute you have one stuff like this, and it's go up to about like 15,000 feet to 20,000 feet, a lot. And if you fly with Thai Airways to Thailand a while back, in the promotion of the Thai tourists, they show you the picture of the light lantern like that, hot air balloons with a small one. So they do it something like this in the north part of Thailand, that the airport has to be closed. So this is a very important issue. And at that time, when ICAO reported the major finding, what the government did was to ask for everyone, if they want to do this kind of thing, you have to ask for permission from the authority. And the problem is the authority was not ready, because when you ask for authorization, you just give a paper. And there are plenty of papers, and it's very difficult. So that time, what we tried to do is we develop a very simple system. Instead of like paperwork, we transform into digital. Everyone here, you have mobile phone, smartphone. Your phone have camera, you have GPS, right? Instead of just launching papers, you take pictures with the apps, it gets the photo, it gets the location, and then all the data sent through the system to the Ministry of Interior, to the Ministry of Transportation, and they can authorize through the system. They can see very clear where it is, how the impact with the, like the aviation, and with the decision support tools that's already implemented in the system, it helps the authority to work on a tremendous amount of paperwork easily. And you see, this is the first year. Oops, where is this? Okay. This is the first year that we implement. And we got a lot of, the circle here is a TMA. It's very dangerous if you see like some stuff like this in a TMA, because like it's between, like under 20,000 feet. And the next year that we implement this, a lot less, because the authority has a more clear idea. So what it was is like the people has an app to ask for permission to do it. They can use the app even to coordinate with the ANSP, the ATC, during the activities. And in the ATC, we have a screen for the controller to see what's going on, to give them awareness. And as well as the CAA, they have another branch of the system linked to help them to make a NOTAM. Because at the beginning of 2016, when ICAO find this, CAA didn't know what they need to do. So what they did was like all the papers, they have one NOTAM. So in one day, Thailand has more than 100 NOTAMs per day in a small area, and you can look it back into the like NOTAM history in the country. So this is the first simple thing that what we did a while ago, and is now still using in Thailand. Yeah, they launched something like this. Before it was bamboo, it's not so high, and people changed to PVC pipe. So that's why it's go up quite high. Yeah. We work together with, like local people, authorities. This is like in the Ministry of Interior, in the city council or something like that. And the system doesn't avoid the old rules. We keep the tradition, all the paperwork, of course. Indonesia is supposed to be the same as in Thailand. You need to keep the kind of works. People have to sign something. So instead of like typing and printing, the system gives automatic report. They just sign and stamp, something like that. So both can be run in parallel. This is one example. We expand. Of course, rocket is quite easy. You cannot control rocket, so it's like a small area. A few years back, we extend that to the drones. So for drones, you might heard the words UTM, the Unmanned Aero System Traffic Management. So we modify the system and implement it with the drones. In Thailand, we have the statistic that already 30% of the agriculture area in the country already use drones for, pesticide to give the fertilizer to the plants, those kind of things. And our system is helping our CAA to, put in place the regulations for the drones, including the registration, the authorization to fly, those kind of things, quite effectively. We have already run the system for a year in the vicinity of 65 kilometers around Bangkok. We have already more than 3,000 users, and they are quite happy because normally when you fly drones, you need to ask for permission. It takes long time, and now it takes them like less than a day, and they get some permission to do the activities. Yeah, and we have like all the stakeholders together. It's me, police, Aero Thai, our ANSP, the airports authority. We work all together. Yeah, just few of small example of like very practical implementation of digital transformation. We don't need a lot of complex things because in the apps, people doesn't need to push more than 4 or 5 buttons, and they can do what they want with all the complete information, not distorted information. So next, jump into the topic that I already presented, but I will do a quick wrap up again about the data acquisition. For eThought, because that time I was came back from France, a researcher in, I'm a satellite engineer by education and by practice, aerospace engineer. So I was trying to think about like how to use in Thailand we have like Lapan here, you have like remote sensing satellite. In Thailand we have the same. We were trying to find the practical way to use our space resource to be beneficial for the country. And one thing is we were trying to do like eThought with a satellite. We work with CGX since the beginning. So the thing is like, what is eThought? Simply speaking, it's a terrain and obstacle data. Terrain is like the nature made or human made, like how it's look like on the ground, right? And obstacle is the thing that over the terrain, very simple. Normally, we always think about like terrain, you have to do a survey, it's a survey job, those kind of things, but with the satellite, it's not that difficult because satellites see a lot of things. In Indonesia, you have a lot of volcanoes, and I think most of the disaster or like the detection of the terrain, this day can be easily done by satellite. And of course, obstacle, we can do that as well. So this is our experience so far. We have already, with CGX, we have already done 11 airports in Thailand, big and small. A lot of things that we learned so far in the country. So the technique that we use, we tried with all the techniques that is available for doing a good survey. Of course, normally it's like terrestrial survey. When you think about survey, you just need a total station with people standing with the pole, those kind of things. Of course, we did that. Another practical way that a lot of people talk about is using drones or planes to do the survey. We did that. And we use satellite imageries. The technique, maybe you're confused why. You just image like Google Earth, you can find the height of the obstacle or building. The concept is like human, we have 2 eyes, right? With 2 eyes, you can play ping pong, you can play tennis, because with 2 eyes, you have 2 images. And with 2 images, you can do the stereo imaging, so it means that you can detect the depth of the object with your 2 eyes. If you have 1 eye, it's very difficult for 1 eye people to know how deep it is. So the same technique applied with satellite. You take the same area with 2 images, and you do the processing, and then you get the height. I will show you how it looks like later in the next slide. And we also implement a way to, this day is very popular, the EV car and autonomous car, right? You know how the car drives autonomously because it can detect stuff around them, right? Thanks to the sensor, which is the LiDAR on the top of the windshield. It's the same kind of sensor, but we implemented with our own way to detect the airport. Yeah. Okay, back to satellite. What kind of satellite do we use? So it's the same as the eyes. If our eyes can see is very clear, very small stuff, good eyes, you can see very detailed things. Before, if you go back 10 years ago, the satellite is not so good. You can see the smallest thing, maybe a house from space, 800 kilometers away, you can see a house. But with this day, the new technology, the satellite can see a lot finer things. Now, with the satellite image, you can see even human walk like in the movie, something like that. It's possible now. So back about like five years ago when we start, the 50 centimeter resolution satellite already available. So we tested with that, with the Airbus satellite. And why we test with Airbus? Because like this year, just launched a few months ago, Thailand has our own remote sensing satellite, TEOS-2, with the same specs as Airbus. So that's why we were trying to use our space resource. But it doesn't mean that if we have no satellite, we cannot use satellite imageries, because it's very easy, not so expensive, readily available, have a lot of suppliers, so it's the easy resource. So we use satellite for this two satellites for it. And this is how the process data from the satellite look like this. So from to image, we do the digital surface model. This is our Suvarnabhumi airport. You can see the details of the plane. It's quite fine, and it's comply with the requirements of the ICAO. Okay, this is another technique that we've done so far by car, because most people will say like we can use drone for the survey, we use plane, right? But imagine if you operate in a big airport and you have to stop the air operation in order to fly drones. It's very, how to say, it hurts, right? So if we put it in the car and we drive around, we get the data without like disturbing other operations. We did a test, like it was quite fine. How to say, it's replaceable and maybe better because you get very high details of all the airports, and this data can be implemented in various ways. So yeah, just to wrap up, what I speak is like there's no magic method to do the data collection. You can choose the one that's most suitable, most cost-effective, and how to say, best for your situation. So simply speaking, for Area 2, with the technology available this day, we can use satellite imageries for the terrain data and obstacle data, with some complements from the terrestrial survey for some small obstacle. And Area 3, of course, you need more details, so we recommend to use LiDAR. If like you can fly anytime, you can use drone, of course, but ground is not bad, and we test that already. Yeah. In Thailand, we did the same as here, but I would say here, the event here is a lot bigger and I would say exceptional for me. Very impressed. So this is what we done in Thailand back in 2018 in Jesta, the place that I used to work under the Ministry of Science. So we did a workshop for ASEAN, and there's an implementation about AMDB with all the Thai aviation stakeholders. Yeah, this is an example of Suvarnabhumi Airport. Now we are working on this project because Suvarnabhumi is going to expand a new runway, the third runway, so that we do it again. But this time with experience, we can do it a lot faster than before. And this is the outcome of ETOT from all the approaches I mentioned. So yeah, some would say like if you see from the procedure designer point of view, you see a lot of charts and graphs, right? But look into another way of this kind of data. I believe that all of you have some point in your life you have to make a PowerPoint. Maybe your boss asks for some of this kind of stuff. So instead of just using ETOT for procedure designer, we try to implement the data into various ways. Like we have a platform, the web portal to show the data. We try to implement it into AMDB, and you can see nice stuff like this. For example, the first time when we showed this to the ANSP, they think about like, how if we use it with the, like the ground movement in the airport, something like that. We have a very precise map, something like that. Yeah. And this is another example of the airports that we did in Thailand for Bangkok Airways, Sukhothai, Trat, or Samui. These three use ATR aircraft, so that's why I put it here. Okay, to wrap up, this is a process to do the ETOT. So of course, everything starts with the QC. We have the DPS, data product specifications, to identify the requirements. And then there's a terrain data set and obstacle. For terrain, we can use satellite imageries. In obstacle, we can use various methods to complement with each other. And the outcome of ETOT, this is on the right-hand side. If we define the process correctly, at the end, you can have charts, grid maps, topographic map, aerodrome mapping database, AMDB, or just ETOT data at one flow, something like that. Okay, and at the end, from seeing a lot of pain points or like some small issues that the customer needs, we were starting to a part of like aeronautical data workflow. There are a lot of other stakeholders that link with it. For example, in Thailand, we have a rules. And I think here in Indonesia, you have the same rules. When anyone want to build a new construction around the airport, you have to ask for authorization. In Thailand, the area is like 6 kilometers on the side of the runways, and 15 kilometers is like area 2 extended by 5 kilometers on the threshold line. So normally what people do is like they have to send the paperwork to the different organizations. And instead of that, we have a new workflow, now working with CAT, our Civil Aviation Authority. So it's a one-stop service. People can check easily, if you can play games in the computer or on the mobile phone. You build buildings in the game, right? You build building in this map. And then you just see how high. Visually, you can see and you can have the exact numbers. And then they can consider if they can or cannot. If they can, they just submit all the registration stuff to the system. And it's one-stop service, yeah. This is another easy example. Another example for data quality control. From what we did so far, we found a pain point. Data originator is not the same for every airport, every stakeholder. It's very difficult to control. Because at the end, for example, Thailand asked the airport to be the data originator. The airports hire someone to do the survey. And the surveyor is different. Some is high quality, some is low. How to control it? We developed a mobile application. Of course, I told you, mobile phone is a sensor, right? GPS camera is here. So we have the mobile tool. Actually, now I can look into every obstacle in Thailand with my phone through the application Dado. Yeah, I can pull up any information. And this is very essential because it's not only for the airport to maintain data, it's for the, every activity is around the airport. Like now in Suvarnabhumi, if you fly to Bangkok, you see a big cranes, they are building a new hospital. And this is temporary. If you not routinely check it, it would be difficult, right? And CAA was like, have a doubt whether they put a light on it or they put a sign according to rules. So instead of like the old workflow, in Thailand, what we are doing is like the one who asks for permission to take pictures. And everything is recorded by who, by which means in the system. And it's linked seamlessly with the ARIS, so the authorities can see anytime that they want. And with all of this thing, oh, sorry, can you go back one slide by this one? Okay. With the satellite, with the new way of collection, instead of doing big chunk of works at once, we can continue routinely monitoring the situation. We have the situation awareness around the area all the time. Incremental updates, something like this. This is a concept that we are working and we are trying to propose. So that's the short presentation. Maybe I went too fast, but feel free to ask any questions. Thank you very much.
Thank you very much, Mr. Wasanchai. So please, we still have 8 minutes time. If you have any questions, ladies and gentlemen, to Mr. Wasanchai. We are really open to, five minutes more.
It's okay. Thank you. No questions. That's good.
Everyone, okay. From here, please.
Thank you very much for the interesting presentation. I would like just to ask you your opinion on the limitations of the satellite data collection. We have the radar satellite data collection and the imagery ones with some limitations in terms of what we can see, thin obstacles. Your opinion on the limitations and how you see the future, because of course we agree that the ideal future will be that with satellite we can see everything. Today is not 100% possible. What's your opinion on this point?
Thank you very much for a very interesting question. So satellite is getting better and better. What I present is 50 centimeters. What does it mean of 50 centimeters? It's like, what is smaller 50 centimeters? We cannot see. 1 pixel of satellite is 50, right? But this is not the best that we have this day. The best that is on the market today is 25 centimeters resolution, so it's 1 times even better than this. And the rule of thumb for the accuracy from satellite data is like 2 pixels. So for us, we use 50 centimeters. So 2 pixels of 50 is like 1 meter. So that's more or less the accuracy. But of course, it's not just doing a snapshot of somewhere that we don't know and we just use that. We need to do the ground validation. But instead of doing like the conventional way you do scan the big area. We just do the checkpoint, and then we check with the satellite data whether the accuracy is fine, and that's a lot faster. So to answer your questions, it depends on the specs of the data. So the specs now is better. So if the specs is better than now, so we can go to that point. Yeah.
Thank you.
Thank you.
Thank you very much to Mr. Wasanchai. Thank you very much for the questions. Do we have any more questions here? Okay, I think one more questions, Mr. Wasanchai, please.
Thank you for your interesting presentation. I'm Hasim from Aeronautical Indonesia. As your presentation before, that acquisition of terrain data and also obstacle data is used satellite imagery. And another one for attribute acquisition use the terrestrial survey. Can you explain us what the attribute should be collected by terrestrial survey? Okay. Thank you.
Okay. So on obstacle, there's not only the obstacle that is like bigger than 50 centimeters, right? For example, the light pole or the thin obstacle, the thin one. So that's why we need the terrestrial survey to confirm. This is one thing for the small obstacle that maybe sometimes it's like not quite obvious from satellite. The second thing that why we need terrestrial as well, because at the end it's the best that people can see the site by their own eyes, right? And with the ETOD data, it's not only the location, it's not like the AIPS before, you need the metadata. And at the end, you need the people there anyway. But instead of just do the people and survey the carpet the area, with the satellite complement with terrestrial, you can do it a lot faster. Yeah. So.
Thank you.
Thank you very much. And ladies and gentlemen, that was the last session for today.
Thank you.
And I think Mr. Wasanchai did it very well. Thank you very much, Mr. Wasanchai. Can we please give a big round of applause for him? Okay, so ladies and gentlemen, we have come to the end of this session, the workshop. And before we close, maybe we want to show you the QR code for you to access the feedback form. Okay, so to wrap up things, we would like to ask you to give us the feedback as the committee, of course. How do you feel? How do you get the information from these past 4 days? Please scan the QR code provided. All right. Of course, your feedback would be very, very much appreciated. And we also have another QR code for the photo gallery, yeah? Okay, so we have been documenting all the moments for these past days, for these 4 days. So if you want to access it, please scan the QR code provided on the screen. Hopefully you can see your face on the gallery. All right, I think everyone is done. Okay, still need more time? Okay, if you need more time, you can also access the QR code on the registration table after this session. So I think that's all, ladies and gentlemen, on the opening session. The committee, of course, Aeronautical Indonesia, the officials of Republic of Indonesia, and also CGX Aero has already welcomed you with a very warm speech. And now to wrap up things, we would also like to hear the closing speech from, the first closing speech would be from Ibu Dina Yunita, Deputy Director of Air Navigation Operation, representing Director General Civil Aviation or DGCA, Ministry of Transportation of the Republic of Indonesia. So please welcome on the stage Ibu Dina Yunita.
Yes. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. On behalf of our Director General of Civil Aviation, Ibu Maria Christie, may we deliver our closing remark. The Honorable Director of Safety, Security, and Standardization of Airnav Indonesia, Mr. Riza Fahmi. The Honorable Administration and Executive Director of French Aviation Civil Service, Mr. Farid Zizi. The Honorable Chief Technology Officer and Business Development Director of CGX Aero, Mr. Muhammad Ali Magales. The Honorable all the speaker from the ICAO Regional Office, French Aviation Civil Service, Airbus, Thales, ATR, Delft Aerospace, and the workshop attendees we are proud of. Assalamualaikum warahmatullahi wabarakatuh. Best wishes for all of us. Shalom, Om Swastiastu. As we bring the curtain down of the Asia Pacific Workshop on Digital Aeronautical Transformation, I am filled with profound gratitude and admiration. This journey over the past 4 days have been an incredible exploration of the innovation and collaboration. And it is thanks to expertise of our speaker, the diverse representation of participants from numerous countries, and the unwavering support of our workshop partner. To our esteemed speaker, whose knowledge and insight have illuminated our path toward the future of aeronautical information management, thank you. Your expertise has not only informed, but has inspired us, and each presentation was a beacon guiding us through the complexities of the digital transition in aeronautical information. Your contribution have been the cornerstone of this transformative experience. Excellencies, ladies and gentlemen participants, your active engagement and enthusiasm have been the heartbeat of this workshop. The diversity of experiences and perspectives you brought to the table has created a vibrant diverse of ideas. We live here not just with newfound knowledge, but with a shared commitment to transforming the landscape of aeronautical information management in the Asia-Pacific region. Dear ladies and gentlemen, a special acknowledgement is due to our working partner, whose collaboration and support have been instrumental in making this workshop a resounding success. Your dedication to fostering innovation and driving positive change in the aeronautical information management is commendable. As we disperse from this collaborative space, let's carry forward the momentum generated during these days. The connection for and knowledge gain are seed that we plant today, anticipating a future where aeronautical information management is more streamlined, efficient, and resilient. Excellencies, ladies and gentlemen, finally, once again, we would like to convey my thanks to Perum LPPNI, Airnav Indonesia, for collaborating with CGX Aero to conduct this workshop, Asia Pacific Workshop on Digital Aeronautical Transformation, to share information and experiences related to digitalization in air navigation, especially in aeronautical information transformation. I extend my deepest appreciation to each one of you, speaker, participant, and working partner. Your contribution have made this workshop a milestone in our collective journey. May the relationship formed here continue to thrive And may our shared vision for the future of aeronautical information management in the Asia Pacific region continue to soar to new heights. Safe travel of you, and may the impact our collective effort be felt across the skies. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon, Home Santi Santi Home. Maria Christi Endah Murni, Director General of Civil Aviation. Thank you.
Thank you. Thank you very much, Ibu Dina Yunita, for the speech. Thank you very much. Such a warm closing remarks, representing Director General Civil Aviation, Ministry of Transportation of the Republic of Indonesia. All right, the next speech, we will hear from the representative from CGX Aero. So please welcome again on the stage, again and again, Mr. Muhammad Ali Megales, as the Chief Technology Officer of CGX Aero.
Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh. I think that the distinguished officials, esteemed participants, as we are concluding this workshop, and I would like to extend my sincere appreciation of all the effort and all the valuable support and guidance and active engagement from DGAC, from Aeronav Training Center, from all the logistics, which were really wonderful logistics, and from all of you. I was afraid that during the 4 days, the attendance will be reduced, but I'm really pleased to see that everybody have continued to come and to participate to the debate, to the asking questions and so on, of this subject of huge interest. Your presence here has enriched our discussions and lent credibility to Endeavour. The GCA Indonesia and Aeronav and Indonesians made this possible. Our collaboration with Aeronav, with Indonesian people, is our great pleasure, and we are honored to do this. And since years now, and I'm really pleased to come again and again to Indonesia. Thank you so much. You made this really smart and an excellent journey for all of us. I have been discussing with different participants, even Omanis from Europe, from Thailand. Everybody has been really pleased with the reception, with the quality of the organization, with all the effort that you have made. And this is thanks to Indonesian people. This is thanks to DGCA engagement towards the future, towards automations. And this is also thanks to all the Aeronav team and management. It was really a pleasure for CGX. And on behalf of all our partners, I'm listing them in alphabetic order so that there is no jealous there. Airbus, ATR, Delph, Frax, and Thales, who accepted and made this as much rich as possible by trusting us, trusting CGX, trusting Aeronav, trusting Indonesian in our capacity to build this workshop. This was our second workshop all over the world, and we are really happy to see the success that it made, even if it is somehow challenging for certain presentation, too much technical, too much. But I think that we need this awareness, and we need to share this. And the APAC region needs the AES to AEM transition, needs a lot of support, I guess. And as asked by Mr. Takata from ICAO, who is asking Indonesia to be a champion in the region. So don't forget this. Prepare your proposition papers for June, I think. That was the date. So I will send Mr. Takata a message to tell him that you accepted his offer. So the IS-2IEM is preparing really more digital and more efficient and a safer future. It is really our duty to fulfill this together. It is a collaborative. And as I saw this morning, really, I was really happy, and I must say it again because I haven't seen it that much, to see the ANSP and the GCA defending, presenting together the same objective, the same way, and even sharing the same slidewares and so on. It's not that common, so congratulations for your collaborative approach, really. Let's continue together to work, to implement, and gain together in this best future. And really thank you again for your commitment, all of you, Arnav, DGCA also, management, and we know the road. We need just to follow it together, collaboratively. And thank you so much, and see you soon, inshallah.
Thank you very much, Mr. Muhammad Ali, for your speech. Thank you very much. You may return to your seat. All right, ladies and gentlemen, now the last speech would be from Mr. Riza Fahmi as the Director of Safety, Security, and Standardization. So please welcome on the stage Mr. Riza Fahmi.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera untuk kita semua. Good evening. Honorable guest, Mr. Pak Sigit nggak ada ya, Budini, representative of the DGCA of Indonesia, Mr. Farid Zizi from French Aviation Civil Services. Bonjour, monsieur. Mr. Muhammad Ali, CJX Aero, Chief of Technology, and Hilal, my friend, Al-Makbali. Assalamualaikum, Sheikh, Mr. Wasan Chai, honorable speakers, Sawadee-khap, and all the distinguished speakers, delegates, and all participants. In this precious moment, I just would like to express my appreciation to all of you that you already have shared your knowledge and experience. So all of us now have a better understanding about the transformation from AIS to the AIM, especially for a region in Asia Pacific. And second, I also believe that during these 4 days of this workshop, you have a very good discussion with a fruitful meeting, I believe you also enjoy the workshop here. I saw Mr. Farid enjoying dancing last night, so it's it's a beautiful moment. And finally, on behalf of Air Indonesia, thank you very much for your participation in this workshop, and please pass our kind regards, warm regards to your family and colleagues, and safe flight back home. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Riza Fahmi, for the closing speech. All right, it's a little bit sentimental for me personally. But ladies and gentlemen, before this workshop is really ends, I want to ask maybe some of you about the impression of our workshop, yeah, for these past 4 days. Any one of you wants to say something maybe to all the participants? Maybe our our forever moderator, Mr. Louis.
Well, I would like to thank all of you at each of the table for the very good participation. Of course, thank you Airnav, thank you Indonesian CA, thank you Airnav Training Center as well, that were all the little hands behind to make it work. It's always a very good moment to share such kind of events with a lot of people from different backgrounds, from different work, from different application, but all committed to make it work and to make progress on our topic. So, makasih to everybody.
Terima kasih. Now, thank you very much. I want to ask the participants, yeah, who has been here for 4 days. Anyone, please? Oh, from this table? Oh, specific person. Which one, Pak? This beautiful lady? Okay. Do you have, anything to say to all the participants?
Yes, good afternoon, and in behalf of the Philippines, I would like to thank everyone, especially the Airnav and of course CGX for inviting us here in this workshop. It was very informative and we learned a lot. And hopefully, going back to our country, we'll be able to share the knowledge that we gain in this workshop. Thank you very much and good afternoon.
Oh, okay. So this is a special request. Where's the delegations from Sri Lanka? Yeah, you. Okay. Okay, maybe do you have something to say to all the participants?
Of course, it's a really pleasure to be here. Actually, I thank CGX for inviting us. We already have the system. It's working very well for Sri Lanka at the moment, and we have a little bit of things to be done in ETOD and MDB as well. And of course, I would like to thank Airnav Indonesia for organizing this event here. So that's about it. So I'm really happy to be here. This is my first time in Indonesia. It's a very beautiful country. So we enjoyed our time here, but we didn't have much time to go around and enjoy the outsides. But I'm really, it's been a really pleasure for us to be here. Thank you very much.
Thank you very much. Please enjoy the rest of your time here in Indonesia. And okay, you raise your hand, so I expect something more from you, okay?
Thank you very much. On behalf of Oman CA, I would like to thank first our partner, CGX, for the invitation and hospitality. I would like to thank all the stakeholders from Airnav, from DGCA, Thales, Airnav Training Center, and France and ATR. It's really a great moment for us. We have spent fabulous days here in Indonesia, totally different from what I expected. It's been really well organized, even from the hotel management, from all the staff. We thank them for the logistics. And this is my first time coming to ABAC workshops. It's really informative and adding privileges and knowledge. I wish to come again, some maybe ABAC meetings. Really, we are progressing in the area, and really happy to know this, that you are progressing well, especially Indonesia, and I hope they will be champion in the AM transformation. Appreciate it, and on behalf of my friends here from Oman delegates, we wish you all the best, all stakeholders, and we'll see you inshallah some other time. Thank you very much.
Thank you very much. We do really hope to see you again in the next Airnav event. Now, I would like to hear from Airnav Indonesia. Maybe the representative from Airnav Indonesia would like to say something. No, the other, the committee, maybe the man, yeah, Mr. Alan? The man behind all this workshop.
Thank you, Mrs. MC. On behalf of Airnav Indonesia, CQ Airnav Training Center, I would say thank you for all the participants, speakers, especially our partners from the CGX Aero, led by Mr. Mohammed Ali and team, Monsieur Luik, Monsieur Manuel, also Madam Leila, and all through the 2023, all our hard work to prepare this event has fruitful into this such a wonderful event where all of us coming here together to have this workshop. And we are also would say thank you for the enough management and all the partners management who share their work for us to this to make this event come to happen for these 4 days. And I think that will be all. Thank you also all the committee members. Without you all, this would never be happen. Thank you.
Thank you very much, Airnav Indonesia, as the organizer for today, for this workshop. Now I would like to request the MVP for our workshop, Mr. Farid Zizi, Mr. Pagi Pagi Pagi. Do you have something to say before you lead the Pagi Pagi Pagi, right?
Thank you very much. It was really a pleasure for me. First of all, it's the first time in Indonesia. And before the technical things, before the workshop, what I have really appreciated are the people. The gentle atmosphere of this workshop, the friendly atmosphere, and together with the seriousness and the work. Something personal, I was the president of the Air Navigation Commission when we discussed the Amendment 37, when we discussed the launch of the PANS AIM, and the first challenge was how to publish the catalog in an HTML in the ICAO documentation. We are more or less 10 years after today. I know the road which have led to those 10 years. I know the remaining road to make it implemented. But what I loved in this workshop is that this is all about exchange models. I will forget about the models. This is for Mohammed. What I loved is this is all about exchange. And this is really information very important. Aviation is first a vehicle for exchange and of course supported by AIM. Thank you very much. Bagi, bagi, bagi. No, smalat bagi.
It's actually really fun to. Okay.
For the European French one, hip hip hip, hip hip hip.
It's not. It will never beating the pagi pagi pagi. Sorry, sir, but it's actually really fun to hear you, pronounce the wrong pagi 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 after several times. Okay, I heard that we have delegations of Cambodia here. From here, okay. Maybe do you want to share your impression after these 4 days?
Thank you. So I've been here for the whole workshop, and first would like to say appreciation to CGX Aero for the invitation to this wonderful workshop, and of course thanks to Airnav Indonesia for the organization of the really great workshop, and of course to all the speakers, all the participants, and everyone here. Thank you very much for the friendship and the great sharing of experience. Thank you.
Thank you very much, sir. Thank you very much. All right, ladies and gentlemen, finally we have come to the very end of our workshop. It has been a good moment, of course, to be here with you for 4 days and to memorize all the moments that we had together. Let's take a look into our recap video. Pacific workshop on digital aeronautical transformation. Can we please give big round of applause for all of us?
As we all know, the provision of aeronautical data and information of today is mainly focused on pre-flight briefing by publishing Aeronautical Information Publication or AIP, supplement, Aeronautical Information Circular or AIC, and NOTAM.
Please hit the go button.
Welcome to the garden of the Asia-Pacific Digital Aeronautical Transformation.
Wow! So that was the video recap from these past 4 days. I saw you. You danced a lot last night. Okay, ladies and gentlemen, now to conclude our event, what if we take a picture? We capture the moment by taking a photo session together. I would like to invite, maybe for a session, I would like to invite the VIPs, attendees. Please come to the stage. Let's have a picture together. And of course, I would also like to invite all the participants on the next session. So please be ready. Maybe you can touch up with the makeup, with your hair and everything before taking the photo session. Now please, to all the VIPs, guests. Okay. Everyone's ready with their pose. Don't forget to put a big smile on your face. Okay.